entire row and a key value. There are ranges of lockable resources, and it's kind of like slapping a hand, making sure that nothing else can touch that data while under modification.
Okay.
In a multi-user database system, locking is natural and expected, and in fact required in order to maintain data integrity.
So locking's a normal operation, happens all the time.
Natural and expected, and we'll see that SQL Server, who wrote the code to do this? Dynamically, SQL Server will shrink and grow lockable resources based on its efficiency rulebook, such as locking just a key value or locking a whole row or a page, all the way up to very large scale locks. For example, I restore a database, well, the whole database is locked then.
Okay, so SQL Server manages the locking escalation itself.
Thankfully, it does all of it by default. We do have some opportunity to stick our hands in the machinery when we absolutely need to. We won't be looking at that. So next definition then is blocking, which we'll see firsthand in a moment. But for now, blocking occurs when one connection is waiting for other connections to release their locked resources. And in a multi-user database system,
happens all the time.
Some blocking is expected. So at what point does this become out of whack?
Probably when it keeps people from getting the information they need.
Yeah, so excessive blocking is undesirable. And then we take this up even one further notch. We'll also see this in an upcoming demonstration. A deadlock occurs when two connections have locked resources and now they're seeking each other's resources.
Okay.
And neither connection can terminate until they have each other's resources. As you can imagine, this would produce an infinite loop. SQL Server does something about it, but I can't give away the end of the movie just yet.
Uh-oh. And it is a movie, right? Catch-22?
Oh, yeah.
Oh, yeah. Okay. So how do we discover them? How do we solve them?
So we've seen thus far that there are often a number of tools for any particular job, and there's no difference here. We have client error messages that will tell us about deadlock problems specifically. Activity Monitor will tell us about locking and blocking. We have Dynamic Management Objects, a separate topic coming up. We have Profiler, a separate topic coming up. And an area which is getting more and more momentum is extended events. If you want to find out more about extended events, there are some people out in the industry that are particularly excited about those, so there's a reference there. Now, finally, deadlock problems are solved. Wait, that's not quite accurate.
I was going to say.
You cannot completely solve deadlock problems. Even some deadlocks are just going to occur.
Yep.
But you want to minimize them. So
okay.
Some of the ways that you'd minimize them would be making sure that the stored procedures that access a series of objects access them in the same order. Okay. Also, think special operations team. When I say spec ops, think of the Navy SEALs. They get in the cover of darkness. They do their stuff, and they're out of there accomplishing their mission before anybody knows what happened.
Okay.
No jokes, please. Also, we'll find out that to a degree, you can stick your hands in the machinery by setting a connection level setting called the transaction isolation level. And then also, you don't want to be browsing data while it's already under modification, explicit or implicit transaction.
So can we take a look at one of the tools that we might use to find blocking issues, maybe?
Yes, let's take a look at Activity Monitor. We'll have some fun here. Now, you'll notice at the moment, for whatever this is worth, I'm connected to the AdventureWorks database. And AdventureWorks happens to have a table here called person.person. It's got about 20,000 rows, just for giggles. And we'll notice that I am freely able to query this. If I look down, you'll see I have about 20,000 rows.
Okay.
So nothing too dramatic right now. But next, I'm going to copy this code. By the way, take a look at the server process ID here.
Okay, process ID 54.
So
got it.
Every connection is assigned, we call it a SPID, server process ID. By the way, a little shout out to SPID. That is the SQL Server, or actually SQL Pass in Detroit. the SQL Pass user group. So I'm from Michigan, so I got to put in a plug for our own little SPID there. We have a great group there. Anyway, yeah, woohoo. So I'm going to create a new query window, paste the same code in here, run it, and what we find is that window by window, I can execute and use the same data at the same time. Nothing dramatic thus far.
So everybody can do everything, no blocking going on.
No blocking at the moment because no data is under modification. So next up, let's make a change. Let's update person.person.
Okay.
And let's see if this would be, as you call it, Rich, a resume, what's the RPE? Resume producing event?
Okay, yeah.
Let's cause a resume producing event, or at least come close.
That typically would be a change that is not a good thing within the database.
And notice my change here. I'm changing all 20,000 contacts to last name Smith without a where clause. Whoopsie.
Okay. That's, capital P.
That's right. It is a collation thing.
Yeah, this database was put in with a collation sequence that's case sensitive.
Yep, thanks for covering my tracks there. And same thing here. This I forgot. Of course, I didn't pre-write out the code for this one, so.
There we go. So the change is going on. It's updating all the records. We got 20,000 records updated, basically.
And to see if it really occurred, let me scroll through a whole bunch of rows here. What do you observe?
It's all Smith.
So I got a whole lot of Smiths, but now let's see what happens if I go to another window and I attempt to access that same data.
Okay, now, is it my imagination or did it actually come back already when you did it earlier?
Now, in my other SPID, I should say my original SPID, the one that's holding on to the locked resources, it actually is able to look at that data. That's a special privilege for that particular connection. But what I'm seeing right here reminds me of Ferris Bueller when he's expected to be in class. Bueller. Anyone?
Yep, there we go.
And of course, this data will never be returned until we have the other transaction complete or terminate. And this is where Activity Monitor comes in.
Now, if I were to get a phone call from somebody saying, hey, I've been sitting on this query for a while, how could I figure out what the cause of that block is?
Exactly, and that's where Activity Monitor comes in. So, strangely, they moved it from the user interface in Object Explorer a version or two ago, and now it's just a button up here in the toolbar. So I click on Activity Monitor. We're not going to take the full time to look at all of these areas, but there's just a lot of great information here. Okay. We're going to focus on processes. Now, you may remember the original SPID that started to modify data was SPID 54.
I remember that. You asked me what it was.
Excellent. And as I scroll over here, we'll see the head blocker, if I was to expand that, SPID 54 is blocking one other connection. That's what I know from here.
Okay.
Next, if I go to SPID 55, we'll see that it is being blocked by SPID 54. So at this point, Rich, you got your phone call. Hey, what's going on? I'm can't seem to finish whatever I'm trying to do. Okay. At this point, one available option to the DBA is to determine which process they might want to kill, or they could, of course, do this in code.
Awesome.
So now I'm going to head back to my original connection, SPID 54, and I will roll back the transaction after I spell it properly. And let's quickly flip over to the other SPID. Observe now, A, I have results, and B, notice all the last names came back.
Yeah, so no more Smith.
So Activity Monitor could be a really useful resource to find out why somebody might be blocked at the moment.
And is that the only way that you can get information on what's going on, George? What's one of the other tools that we've got?
Oh, we're loaded with tools. And next up, we're going to take a look at Profiler. Profiler is broader than merely locking tracking. Think of Profiler as capturing general kinds of activity that's going on in SQL Server. And in fact, as I move to the topic slide, this is going to introduce us to the topic of tracing, which then will lead us into the topic of what Profiler, and what it does.
Awesome.
So what is tracing? Tracing is the under the covers capturing of activity by the SQL Server process, and we'll find that it can record and track all kinds of activity, which we refer to as events that are contained within event classes. So notice the hierarchy from the slide here. I might have one event class, like the locking class, and then the deadlock or blocking events. Another class might be the T-SQL class, and then T-SQL statement begun, T-SQL statement completed would be events.
Okay.
Now, using system stored procedures, I can turn tracing on, determine what I want to capture, then perform all aspects related to tracing completely without a user interface. And the link that I have at the bottom of the slide will lead you to a further study there.
Awesome. Is it only through stored procedures? Is there another way that you can get that tracing going?
Well, for some of us who are mere mortals, or at least just exploring, keep in mind there is a graphical user interface into the tracing subsystem. This is a good way to get a head start. Brace yourself, Rich.
Uh-oh.
I've heard of stories from some of my student customers saying that based on being told by Microsoft Product Support Services that they have to turn this on to capture something, that it will generate gigs and gigs of data in no short time or in quick time frame.
Absolutely. The bigger the database, the more the data is going to be generated.
So you'll observe, although the screenshot is a little bit detailed, what you see is a laundry list of captured events, and then when one particular event is selected, you get a lot of detail about it.
Awesome.
So Profiler is a graphical user interface tool. I will add that it adds significant amounts of overhead to the tracing subsystem, which is why the pros like to trace using the system stored procedures.
Which, by the way, there's an easy way to get to, because once you've got your trace configured in the GUI, you can save it and generate the stored procedures from the GUI, from the file menu.
Fabulous. So I'd like to think of Profiler as a three-legged stool configuration. That's what the graphic is implying here. One of the first things I have to do when I'm configuring trace is determining the particular events in their particular event classes. That is, of course, of major concern, and we'll find out that a template can be used to help us along the way there. There are some pre-made templates, and Rich, knowing that you're overzealous as you are, you can make your own templates, and then readily use those. So after I pick the events and event classes of activity I want to capture, I then may need to go to an extra level of detail in that there are standard columns of information like the start time of an event, the duration of an event, other aspects of what gets captured, but I can add more columns to what gets captured if there's some extra stuff I need to capture. This will make more sense when I do my demo in just a moment. And finally, just a general rule when it comes to capturing data of any kind. Only capture that which you're actually going to bother to look at or that you actually need. And especially, you don't want to have to find a needle in a haystack. And I will promise tracing can create a haystack. Now, we have to have another drum roll.
Uh-oh. Drum roll, please.
Awesome. One of the niftiest things that came about with SQL 2005 is the ability to take Windows performance monitoring data and profiling data and merge them into one screen where I could then capture basically I could capture data in both environments and happen to see if there's any correlation of system activity to SQL Server activity. Okay. This was brilliant and really nifty, and if you want to see what that might look like, I have a link there. Also, some of you are going to want to take Profiler to the next level, and there's a book, a free ebook that's been put out by SimpleTalk. I think it's Brad McGee. If anybody wants to double check me on that, go to simple-talk.com/books. By the way, I'm big on free stuff.
I think everybody likes free stuff.
Big on free stuff, and SimpleTalk, it's armed by Redgate. Redgate does a great amount for the community. They have a bunch of free ebooks there. So if nothing else, attending this segment, you just got a few $100s worth of free ebooks. So we're good.
Absolutely.
Well, next up, let's not hold off any longer. Let's show them how Profiler works.
That sounds like a plan. So what are we going to do here? We're going to go and try and generate a deadlock and see what happens?
Exactly.
Sounds good.
So first up, let me go ahead and configure Profiler to be able to capture the information that I want. Thanks for letting me tidy up for just a little bit. And now I'm going to go to my Start menu. We'll go to All Programs. Yes, SQL Server 2012. But now I'm going to go to Performance Tools, different compartment. And notice, we got both kinds. That's a Blues Brothers reference.
Uh-oh.
We got both kinds. We got Profiler and we got the DTA. So let's open up Profiler.
You realize that's going to go over the heads of a lot of people, myself included.
Yeah, okay. Being an 80s kid, Blues Brothers, you couldn't hardly escape. But
I wish I could say I was an 80s kid.
yeah.
All right, so we got Profiler coming in.
Now, by virtue of seeing that we have to authenticate, this tells you that Microsoft wouldn't want just anyone, or I should say, you as a DBA wouldn't want just anyone to be profiling and putting a burden on a machine. So after we validate identity, we're going to take a look at the first leg of the stool. So let's just call this, what's today, Wednesday?
We'll just call seems like it.
We'll just call this Wednesday AM Trace. Sorry for those that are 12 hours away, but we are glad that you're here. Next up, I can use one of the standard templates, remember.
Those are the ones that choose it for you.
Overzealous Rich might have some of his own on his own machine. Okay. And then I have to determine where I'm going to put the output of the trace. So I can save that to a file. I'll just pick any old location. If this was going to accommodate a large amount of data, then I'm going to have to put that somewhere else, or at least be concerned about where it goes.
Awesome.
So remember, this dictated the events and event classes, which we're now going to see when we go to the next tab here, Event Selection. So the standard template we'll see has picked these particular event classes in bold, and then these particular events in those classes, and then also standard, it's taking a look, whoops, that's nice, you can undo the most recent scribbling. Notice the columns, or I should say the standard columns of information here.
Okay.
Now, I'm going to adjust one of the legs of the stool by saying that I want to show all events, and in particular, observe all of the classes that we have. I don't really want to look at that in super great detail, but I do want to go to the locks area.
Okay.
So from here, I'll pick, let's say, deadlock graph, lock deadlock, and lock deadlock chain. Let's say I have an application and I seem to be getting an inordinate amount of deadlocks, more on the definition part there.
All right.
Okay, next leg of the stool, I get my standard columns, but maybe I want to expose those particular areas that offer other columns. So I might want, let's say, the database ID to be accompanied with the deadlock chain and other ones.
So if there is a column for some events that's not included, but you're filtering on it, will that event show up in the trace or won't it?
Only that which I have selected is going to show up, and not only that, but I can also filter such that events that would normally be captured, they won't go on the trace. And notice, I don't have a huge amount of criteria, but all the ones I would probably want, filter by database that I want to capture, only activity in this database, or all except a particular database. And also on behalf of an application, particular user. So I have a bunch of criteria there. So that is the third leg of the filter, and now I'm going to run my profiler trace. Now on a busy machine, this is just a lightly loaded virtual machine, almost no activity. It's not going to generate a lot quickly.
That's
on a busy
good. We
machine,
won't have to look.
On a busy machine, this would be scrolling and probably going crazy. So next up, let's take a look at some activity, or generate some activity that's going to be captured. And module 2 module 3 deadlock. So let's first go to the market dev database. Sorry, we're already there. And I want you to make a mental note of a couple IDs in particular.
Okay.
So we have two different prospect IDs. So 6800, 7800, they're going to be easy to remember. Now, movie spoiler, two different connections are going to end up requiring each other's resources, never to be finished. This is exactly what a deadlock is.
Okay.
So when two resources, I should say, when two connections have holds on resources that yet need each other's resources, this would produce an infinite loop of those objects never being released. And we'll have to see what SQL Server does about it. That I won't tell. Now notice, every connection has a SPID, and I can use add@SPID to determine what the SPID is of my particular connection.
All right.
So let's also make a mental note. I'm in SPID 55, and what I want to do is update the first ID in the first connection.
Okay, so we just changed one record.
So I have data under modification. Notice, very sneaky, I did not commit the transaction, so now a lock is held on that resource. All right. Now, for what it's worth, I have a couple different ways of showing locks, SP lock, and later on in the module, we'll look at dynamic management views. So we'll just leave those alone for right now. Okay, next, open up another connection, and I'm going to have to paste the code below into that window.
Okay.
So let me take a look at that. Observe, new SPID, 57. We'll also notice, we can confirm that, that's sort of a duh, but now I want to put the second ID under modification. And it's under modification, also notice I did not commit it.
All right, so we changed one record in the first window, a different record in the second window.
And did not commit either. So notice I'm now back in the first connection.
Okay.
And I'm going to attempt to update the second ID. Now what I'm going to do...
It's kind of sitting there.
Now what I'm going to do, so notice grinding, grinding, grinding.
Yep.
Now I want to go to the second connection, and I want to attempt to update the first resource.
I see red.
And
red is not a good thing.
So how is this for one of the world's scariest messages? Well, maybe not the world's scariest, but transaction process blah, blah, blah was deadlocked on locked resources or unlocked resources with another process and has been chosen as the deadlocked victim. Here's when you know you're overdue for a vacation. If you know IP addresses of certain machines off the top of your head, you're overdue. And if you have memorized SQL Server error message numbers like 1205,
1205 is every DBA's nightmare.
Rich, it's time to go to the Bahamas then.
Never a good thing. Never a good thing.
So let's go back up to Profiler now and see if it found anything. Oh, you know what? Did I run it?
No, I think you're connected to the wrong database. I have a feeling.
Do you know what? I connected to the wrong one. That was dumb. All right. Well.
Oh, well.
Yep. I needed to connect to ProSware.
AdventureWorks. Well, life goes on. But you know what? The deadlock graph that gets generated does show you all the objects and the statements being executed. So
what do you think? Is it worth it to run this again, or should you want to go on?
I think it's time to get to the next topic.
Well, the drama here is that I would have actually seen in Profiler the deadlocks being listed, and then graphically I would see how they acquired each other or attempted to acquire each other's resources, and in hovering over the deadlock graph elements, I would get useful intel for troubleshooting. So that was really the point of that one.
Awesome. And another technology we've got available to us over and above tracing and Profiler would be auditing. What's that all about, George?
All right, so in the same way that Profiler and tracing can capture data, auditing can capture data too, but for a particularly different sort of purpose. So let's take a look at a number of the auditing techniques, and then we're going to focus on one particular type of auditing feature, which literally has the name
auditing.
SQL auditing. Yeah.
I like that.
So in the past, a little legacy, we had some military standards or governmental standards, I
Yep.
guess you would consider those. C2 and common criteria were their names. These were, is implementable a word?
Yeah, it is. It works.
Okay, well, it's a word today. So you could implement those in SQL Server at the expense of lots of overhead. Now, a funny thing about auditing is that you might need to turn auditing on to capture activity,
Yep.
but you don't want the people that you're trying to capture to be able to turn it off.
That would
So
be a good thing,
there
yes.
are some safeguards there with the auditing features, but it turns out those were they had a lot of overhead and have fallen really out of mind share, at least in the SQL Server community. So we'll consider these as older methods. A lot of overhead associated with those.
All right. What are some of the other ways we can audit the database and catch information?
We have a bunch of different triggers that exist in SQL Server, DML triggers, so we could capture data modifications and then store that or use a trigger to store that in a table. Same thing with modifying database objects, like if I create a table, if I modify a table schema, I have DDL triggers. We have login triggers, but it's good to know that they're there. They fulfill a particular purpose, but there's a trigger limitation.
What's the big limitation?
The limitation is someone can turn it off.
Ooh, that's not a good thing.
So you don't want the person whose traffic you want to capture be the one to turn off, the auditing.
That would be like giving the fox the key to the hen house.
Something like that.
Oh, dear.
So next up, let's take a look at the feature SQL auditing.
Now, this is the one that they want us to use going forward, right?
That's right. So what does this feature provide compared to other types of general auditing methods? It's very granular, similar to some of the previous auditing methods, and we can track not only instance level auditing activities, but also database level auditing activities. And it leverages a technology that's now part of SQL Server, extended events, and it's essentially, a pre-configured extended events environment.
Okay.
There's some terminology we're going to go through during the demonstration that you'll have to become familiar with in order to implement auditing. And we'll see the configuration steps. There are actually a series of configuration steps involved in this.
So what do you think? Why don't we just go and walk it through and explain it as we show it to you?
Good plan. All right, so let me close Profiler.
All right, so SQL auditing, again, it allows us to capture event activity similar to what Profiler does, but a little bit different technology.
All right, and here we go. Now, one of the things that we have to determine when we're going to audit is to determine the destination of our audit data. This might be an important concern from an integrity standpoint. We have two destinations of the log data.
And what are those?
We have the application log, and we could also specify a file system location that maybe we exclude access to.
Okay.
So with that, I'm going to create a server audit, server audit object. Notice the name of this. We'll call it market dev log and dictate the destination of this.
So we're going to be writing the messages to the application log.
To the application log. Next, I'm going to go to the database level, and I'm going to create an audit specification. Now, there are server level audit specifications and database level audit specifications, and they dictate what it is that I actually want to track or cover. So
Okay.
the code is fairly readable here. I'm creating a database level audit spec. I give it a name, and then on behalf of a particular server, and the activity that I want is any selecting within or activity on the marketing schema objects. And notice whom I'm tracking would be anybody within public, which means everyone.
So you define the action, you define the object, and you define the user that you want to audit.
That's right. So if I wanted, true to really all over the SQL Server product, I have metadata to retrieve any conceivable information that I want. All right, next up, we have to throw a switch on.
Okay.
So pointing to the master database, I have to throw a server level switch on, alter server, audit market dev log, and I have to turn that on. Now that I turn that on, I'm also going to have to turn a switch on at the database level.
Okay.
So point to the proper database, and now that specification that I created a moment ago, I have to turn on as well. And
So
next up, the bear trap.
All right, let's see it, George.
Let's go ahead and perform some activity that may be caught and some activity that might not be caught. Notice a bunch of metadata queries that you can run. I'm going to leave that just in the code here.
Okay.
It was brought up on the break time that some of you are interested in the code, and the code will be made available.
We'll have details coming up a little bit later on how that's
I'm
going
flattered
to work.
that you think some of this code is actually right from Microsoft, and we'll give details on where you could get a hold of that. But yeah. All right, so notice that this object is within marketing, and this object is not within marketing.
Okay.
So I'm going to involve some activity that should be audited.
Interesting.
That's okay. That actually was not activity to be audited. So
Nope.
now we need to take a look at the application log.
So we're going to go out to Event Viewer, look at the application events, see what shows up.
Yep, so let's go to Windows Logs, Application Log. Audit event. Da-da-da-da-da-da.
Very cool. Now you can also get that activity by going to Audits in the GUI, correct?
Yeah, in fact, I can configure a lot, really, for all practical purposes, all of this within the graphical user interface. So all of that is available.
Cool, cool. So there's a lot of information about activity and tracing and all that good stuff. What about getting activity about getting information about configurations and how my databases are set up and things like that? You know, is there stuff that we can learn there?
So SQL Server is a dynamic environment. There are things that are moving, changing all the time. So that's one point. Next point, there are all kinds of facts that I might want to get about my environment, and in increasing measure, there's a recommended way to get that information, and this information is retrieved via catalog views and dynamic management objects. So these are the things that we're going to take a look at in this next little subsection. So I want to start off with a definition, Rich.
Please do.
So what is metadata? Metadata is retrieving information about information.
Okay.
So there are very typical pieces of information that database administrators, maybe even database devs would want to retrieve. Fortunately, Microsoft has laid it in our lap or made it accessible easily through normally queryable objects.
Okay.
Now, I'd like to demonstrate something, so if you guys would flip over to my, my virtual machine for a moment. Let's say, just on a whim here, I create a new database.
Okay.
So let's call this busy database, and immediately, whoops, and immediately we'll go ahead and create it. Now, in my list here, I see my database, and observe when I go to views, I don't have any views, user-defined views.
No, we haven't created anything.
But observe what I have immediately accessible under System Views. Now, for the most part, information schema views, they're queryable objects that they have, but they seem to be falling out of favor. I'll say that's an opinion. What seems to be gaining momentum is this remaining set of objects starting from here and then going downward. Notice the sys prefix. So generically, we're going to call all of these catalog views.
Okay, so the catalog views.
And some of these are queryable objects that get instance level information, something like sys.databases.
Okay.
Or I have other objects that are at the database level, like sys.tables.
Now, the catalog views are mostly static information, though, right?
Exactly. So catalog views are static information, but as I scroll down a little bit further I'm going to get to some objects that have a different prefix, an added prefix. Notice the sys.dm underscore prefix.
Okay. What does that DM refer to?
So the DM refers to dynamic management object. And if I can flip back, actually, if you guys would flip back to the slides then. Let's go through a quick little classification system. But before we advance, you'll see that having normally queryable objects, our static catalog views, and our dynamic management objects, I can apply all of my normal querying mechanisms to get just the information I want. If I can add a little editorial comment, generally speaking, the catalog views and the dynamic management objects provide way more information that you care about. So you're going to come up with your own custom script code. You're going to use where clauses, column lists. You can aggregate where clauses. Like I said, all the normal queryable mechanisms. You'll come up with your own custom code. Timeout. There are lots of resources out there where they already have some of these queries made, and you can appropriate them rather than write them yourself.
Yeah, it sounds like a plan to me.
All right. I don't know if we'll have enough time at the end of this session, but if there's one of the sessions today where we do have a couple extra minutes, I'll talk about some of my favorite websites that I think you should subscribe to. And I have swallowed my own medicine. I am also a subscriber of everyone that I would recommend.
So would be a good thing.
Moving on, you could argue that there are two major classifications of any of the dynamic management objects, that is, those that have the sys.dm underscore prefix. Generally speaking, we call all of them dynamic management objects, or DMOs.
Okay.
Further, those that require no input we refer to as dynamic management views, and those that require input are called dynamic management functions. Strangely, I can't just look at the name of them and determine, wait, that's a function, that one's a DMV, or dynamic management view.
True.
I've got to put a plug in for Books Online. I know you're a big fan of Books Online.
Best help system ever written.
Every single dynamic management object, probably every catalog object, you can get all the information you want about in Books Online. So that part is good. Now, let's a point of reality here. So I've stated we have DMOs and then DMVs and DMFs in sort of a hierarchy, and everyone mangles the names.
Yep.
We'll just graciously suffer everyone that doesn't know our taxonomy, sorry, and just roll with it.
There you go.
Now, for those that have particular interest, another Michigan person, an awfully busy man, part of one of the West Michigan user groups, Tim Ford, has co-written a book called, I think it's the Periodic Table of Dynamic Management Objects. So that's a resource you have. And also, being a frequent speaker, conference presenter, he had a presentation that's still out there online. You could easily Google for it here, called the Periodic Table of Dynamic Management Objects. A couple of other resources to run with before we actually take a look at using some of these. At Redgate, one of their free ebooks is called the DMV Starter Pack. Not only an ebook reference, but also a bunch of code that you can use to solve very typical problems about a busy SQL Server environment.
That's good thing to have.
And then I know at one time Quest, which is now more recently owned by Dell, they had a poster with, I don't know, a whole bunch of dynamic management objects listed on it. But now that you know that there are resources, let's take a look at some of the dynamic management objects and see some of the things that we can obtain from them. So here we go.
So what are we going to be looking at here, George?
So we're going to take a look at really just a strafing run, a big picture survey of some of the dynamic management objects, and we'll have this conclusion. Man, I can get anything. I can find out anything that I would want to. Honestly, you might have to write a little bit of gnarly query code, but you can get what you want. So that's the conclusion you'll have. First, let's take a look at a dynamic management object called sysdmExec requests. Any input required here?
Doesn't look like it to me.
Nope. So this would be classified as a dynamic management view.
Okay.
Now, we'll find that if we scroll one of the columns, and this is good insight into one of those that has an awful lot of columns, somewhere in here we'll find the column is user session or is user process. Heck, off the top of my head, I don't even remember where it is, and I probably passed it anyway.
Yep.
You think I passed it? Okay.
Probably.
So let's take a look. Is user process. Can I skip scrolling?
Yes.
Let's just use a where clause and execute this to only show non-system processes. So I'm using a where clause, is user process equals 1. Next up, we'll find that often it's valuable to combine the use of dynamic management objects. These are also DMVs. So A, we're joining, B, a where clause, and C, we're specifying particular columns. So we're going to use that column to filter the currently executing requests by joining the two tables on session ID. So notice this has revealed me.
There you go.
Next up, note we can also retrieve details of the SQL batch that's being executed instead of just the handle, and we can do this with a function. sys.dmexec SQL text function, and like I said, if you memorize some of the function names or DM objects by name, you need a vacation.
Seeing as there's several hundred of them,
Yeah.
I would agree with you.
So now I'm not only going to perform a join on a couple of DMVs, but then I'm going to outer apply that across a dynamic management function. Let's see what this provides. And we'll see this will supply me, the program name I'm using, the general statement that I'm using, and my actual query code, and a couple of other facts as well. Okay, take a deep breath here, Rich. Now, it says, don't be too concerned about the complexity of the subquery below, but note that it's possible to find the actual statement being executed rather than the batch.
Can I let it out now?
Yeah, there you go. Sorry. All right, good job. All right, so that is somewhat gnarly query code, but as I scroll here, notice I get statement.
Wow.
This would be even more fun, if I expanded that all out.
So you can do a lot of the things that you're doing in Profiler and event tracing and all that through queries as well.
There's so many ways to get information. Part of this might be my preference, and so let's see.
So what about, is extended events similar to Profiler?
I'm sorry, say that again?
Extended events, I've heard a lot about that. Is that similar to Profiler? Are we doing the same kinds of things there?
I saw a comment from the student or from the attendee pool there. Extended events are not going to be part of this session. They're not in detail really at all on the exam. So we're only looking at Profiler for this point. Yep, Profiler is a deprecated feature. That means, here's my nickname for a deprecated event. It's a dead man walking. It's going to be going away. It's not gone now, but it's going to be going away. In some cases, we're not even told in how many versions it'll go away, but it's going away.
So extended events is there. It does the same kind of functionality, but at this point, it's not really a big objective on the exams, and Profiler's not going away anytime in the short term.
That's right.
All right.
Okay, so next up, one of the things that you might be interested in is a precious resource, and that is the procedure cache. So I'm able to query, let's just summarize, all the points of interest. So I can get plan cache details. I can find the top 10 executing queries. Lots of good stuff here. Like I said,
cool.
There are places out there that will give me, that will hand me this code in my lap and can help me solve various problems. So let's go ahead and move along now.
All right. So the other thing, we've got these dynamic management objects, we've got the catalog views, we've got Profiler and all that. Is there a technology that kind of brings all that together and pulls it into a way that it becomes useful for us over time.
Especially. There's the D in dynamic management objects, which describes that it's dynamic information. It's changing information. It's not persisted in any way, which brings us to our next topic. Might it be wonderful, by the way, this is where you say yes.
Yes.
Might it be wonderful if I could capture some of that performance data and some of that tracking data, store it long term, maybe even be able to create some wonderful reports off of it? Of course, the answer is yes. General troubleshooting rule. If I don't know what normal is, how can I take my current condition and determine if something's wrong or not? Have you ever had a he said, she said, some kind of thing?
Yep.
So let's take a look at the management data warehouse.
Cool.
All right, now the management data warehouse is a regular SQL Server database that I can make that has some other mechanisms placed on it to grab data from either the current instance and or other instances.
Okay.
It's configured through a wizard. Actually, I haven't looked into seeing if I can configure it in code, but I configure it and set it up with two different wizards. What it ends up doing is setting up schedules, SSIS packages, and jobs to grab performance data, put it in what they call the management data warehouse, and also build some wonderfully accessible reports that are viewable from Management Studio.
Very
really nifty.
cool.
I know
Very cool. How do you set that up? How do you get Data Collector up and working?
So as you can see from this slide, there are two wizards that you'll invoke. First, I have to get started. I have to create the management data warehouse, and you'll see that from the first radio button, implying that I'm going to run the first wizard. After that, I then set up data collection and do the rest of the configuration process. And you'll see in going through these two wizards, two sets of roles exist. There's a role for management, and notice there are three different roles, each with their own privileges. And then there are specific database roles for configuration purposes.
So once you've got the data collector set up, you've set up the management data warehouse, what's the next step?
Next is allowing it to do its work through the scheduled jobs, and you'll see a couple of two of the three reports that can be produced. Let me ask a rhetorical question.
Ask away.
If there were resources on a SQL Server system that you were concerned about, what would be some of the ones you'd be most concerned about?
Probably disk space.
Disk space?
Maybe memory or CPU utilization. I mean, those are the things that get used on a computer.
Sure, and if you guys will go back to the slide, you'll take a look that, at least on behalf of these two reports, they show exactly what you were talking about, Rich. Those things like disk usage trends, CPU usage, memory, etc. Some really good stuff.
So can we take a look at how to set it all up and get it going, George?
Sure.
So walking through, you're going to show us the wizards and how it all comes together. And at the end of the day, hopefully, we have a data collector.
That's right. So you'll notice from here under Management, let me just collapse a little bit to simplify the user interface. So under Management, you'll notice I have data collection, and if I refresh, well, I don't have anything there right now. General rule of thumb in Windows, when in doubt, yep, I'm going to right-click. So right-click, configure the management data warehouse. Well, here are my two radio buttons. Let's get started with the first one. So first up, what instance do I want to put the warehouse on, and do I already have a warehouse, or do I want to make one? It probably wouldn't be a bad idea to already create one ahead of time, but skipping a little of the detail, let me go ahead and make the management data warehouse.
And that's just a standard create database dialog.
Standard database. So here is where I could map logins and users to the management roles. I don't need to do any of that just yet. And from here, I can click on not Swedish, but Finnish.
That would be the collective groan from the peanut gallery, please.
So if I didn't get beat up enough on the last break for my comic book reference.
Keep going.
Next up, we'll run the wizard again, set up data collection. So enter where you want to cache collected data locally before it's uploaded.
Okay.
I'll just pick a dummy location for right now. In reality, you would probably want to pick a location that you're going to have enough space for. So
Okay.
let's go ahead and designate the server and database that will host the data warehouse.
All right.
And honestly, I thought I put that on Prosware, but maybe I put it on the
You put it
default
on
instance.
AdventureWorks, yep.
Yeah, okay, so there's our warehouse. It's always nice having a second set of eyes. So let's click on Finish.
And the wizard does its wonderful thing. It spins, it grins, it winds, it dines, it slices, it dices, and
Yeah.
it's done.
And there now, what we would want to do is generate some activity, give some time to let the scheduled jobs work to collect data, and then we get the nifty reports. So right-click on Data Collection Reports, and there are the 3 very pretty reports.
Awesome.
So that is
very cool.
Those are the basics of configuring the data warehouse. So in this module, we took a look at SQL Server being a dynamic environment, lots of ways that are lots of tools that we have that can give facts. Facts can produce conclusions, and from the conclusions, we can then implement some changes.
Awesome.
So
Thanks a lot, George. We will be taking a meal break now. We appreciate the time you've spent and look forward to seeing you back here at the top of the hour.
And I got to tell you, I'm excited about some of the stuff we're going to look at this afternoon.
Oh, yeah, we're going to have fun. We're going to have fun. See you in a bit. Welcome back, folks. Thanks for coming back. We are here to finish up this afternoon's Administering SQL Server 2012 Jump Start. I'm Rich Curry. I'm here with Mr. George Squillace, SQL in his name. George, what do we got coming up next?
Well, for the back 9, we have some good topics. Now that we have a solid platform of SQL Server, we've installed the product, have configured server and database level options, learned how to make sure the product is running optimally. Now we have to take a look at some data stewardship. That'll be managing data module 4, security and high availability to follow. So for this particular module, we're going to take a look at managing data, data stewardship, things like that.
Alrighty.
Moving over to the overview, there's a phrase that the DBA should take to heart, and that is tag IMIT.
Usually we end up with everything.
Tag IMIT. So I am, as the database administrator, I am the data steward. So we'll take a look at protecting data as a data steward, which means not only duplicating it via the backup process, but also when the chips are down, Rich, we got to be able to put it back down. Got to be able to restore. So we'll look at backups, backup strategy, restores, and then some other database maintenance and administration kinds of tasks like moving databases entirely or just relocating their files, maintaining database integrity, some other tools like that. So that's up for this particular module.
All right. So, of course, whenever anything goes wrong, you want to make sure that you have a
backup strategy or a restore.
A backup.
Yeah,
absolutely. We got to be able to back it up so that we can recover it later.
Now, I imagine, especially for those of you that have a good amount of experience with the product, of backing up and recovery models, they're not brand new, but I do want to challenge you for the exam that you've walked all the way through the process of learning the different backup or different recovery models, different backup types, and I will tell you, there is an X factor, some aspect of unknown when you actually come to a point where you have to restore, recover a database or a whole system, some unknowns that are going to pop up. You must have walked through the process to recover, and that way when the X factors come up, it won't be any more difficult than otherwise. Absolutely. So the first thing we have to take a look at is a quick look at the recovery models. Note there are only 3, so that makes the decision-making process a little easier.
As long as you know what they are and what they do.
So the model database is used whenever a new database is created. It's copied, so whatever options it has, those will be applied to a new database unless they're overridden. The model database after installation has the full recovery model, and this is the most complete recovery model. It permits point-in-time recovery and recovery from failed media. Bulk logged recovery model, actually I'm going to skip to simple for a moment. With the simple recovery model, we'll find out that we are able to restore full backups and differential backups. But the way that the log file is maintained is different with the simple recovery model. Transactions after they've been logged into the log file and then rolled forward into the database are truncated, which is where the previous name of the simple recovery model got its name, truncate log on checkpoint. So there's no data in the log file that permits point-in-time recovery. And in fact, if you try to perform a transaction log backup on a database with a simple recovery model, it's not even an available option. So now picture straddling between two different possibilities. That's really the bulk logged recovery model, and it's not really a perpetual model that you'll stay in. This is an interim model that you'll use when you're going to perform bulk operations. So the point is certain operations are minimally logged, and when in the bulk logged recovery model, you'll take up less log space, there's less overhead with the bulk import operation, so it's more efficient.
So the full model recovers has the ability to trace and track all of the work done. The simple just gives you enough to restart the database if you need it.
Exactly. So there are times where maybe I have a developer copy of a database. It doesn't need to have absolutely everything to the nearest moment. Or maybe I have a database that I can refresh easily from some other process. So a simple recovery model might make sense for some of those. I have the options because they're reasonable in certain cases.
So what about the backup itself? What are the different statements and options that you can use there?
So you can see that not only do we back up the database files, but we also have a separate statement for backing up and protecting and managing the log file. There are a bunch of options that come along with each of these. And in particular for the test takers, you are going to want to know the most popular options, like with differential, with init, no init, format, some of those other ones.
And what about making sure that your backups actually were successful, that they worked, that you can go out and make use of them later?
Sure. Picture a scenario where I might have an awful lot of databases and an awful lot of backup files. Now, let's say you're the primary DBA, you're out with an unexpected gallbladder operation.
Oh,
Tag,
boy.
I'm it.
Yep.
Now I'm the one that has to go in and restore, and I might not know what your particular strategy was for storing and naming files. So now I have to take a look at the contents of those backups before I actually use them. So we have a number of integrity and fact-finding kinds of statements that we can use against backup files.
Cool. What are those all about?
So we have restore verify only, restore header only. We'll see these in an upcoming demonstration and the types of information that they provide. Lots and lots of facts other than one of them.
What's that?
Three give a lot of facts, and we'll get to the one that doesn't give us a whole lot of information other than okay or not okay.
All right, so leave me sitting on the edge of my seat. We'll come back to it.
As I often do.
Yeah. All right, so do we have the same concerns about backing up system databases that we do backing up user databases?
Some general concerns are the same, but there are special considerations related to the system databases. First of all, with a couple of the system databases, if they are corrupt to a certain degree, you're not going to have a usable SQL Server. Let me be more clear. So the master database, if it's corrupt to a certain degree, the SQL Server service will not start.
Okay.
And in that case, you don't have a SQL Server instance. So that's obviously a game breaker. Additionally, if your MSDB database is corrupt, then the agent service will not start. And although I've never run into this, if the model database in some weird way would get corrupt, I don't know how, but if it were, that could also actually stop the SQL Server service from running.
Okay.
Additionally, Additionally, you don't want to change the recovery models of the system databases. The right there means there is the possibility of changing that on MSDB if you wanted to, but more than likely you're just going to back that up in full every time you back it up, and you would restore it in full rather than worrying about a point-in-time recovery. And I know, sorry, don't press me off the top of my head, but with one or more of the system databases, even if you change the recovery model, it doesn't change what actually happens. That's a peculiarity with them.
Cool. So why don't we go take a look at that? George is going to show us how do the backup statements work and the different effects that they've got, and some of those backup integrity statements that he was talking about just a minute ago as well.
All right. So let me make sure I see what instance we're connected to, just to double check.
Okay, so
I'm going to create a database that we'll use for our purposes. And some of the information that I used for preparing for this presentation is this link up there. I just wanted you to see that. Now what I'm going to do is create a destination for the backup, and I'm going to use what's called a device. Pardon me.
What does a device do?
A device is a friendly name. Really, it's no more than a convenience feature. A convenient destination, friendly name that I'll use for a backup destination, rather than some lengthy, complicated path with spaces and things like that. So I'll create my device. Strangely, if you were to right-click on that device under Server Objects, Backup Devices, and you tried to look at its contents, it would say that nothing is there right now. So there won't be any content until you actually back that up. Now, I'm going to put some data in the database, and then I'm going to back it up. I'm going to use just a basic backup statement, back up the database, a couple basic options, and this will be the first backup that I have for that particular database. And let's see what I biffed here. Did I add an underscore in the name?
Nah, it was giving me a device. The file doesn't exist, I believe. So,
well, we'll just make this easy.
Yeah, just specifying it, and that brings up a good point that you do have the ability to use devices, or you can code the actual location in using single quotes around the location.
That's right. So this time, let's go professional and check my code. Well, Rich, we're getting a little
file equals disk equals.
Oh yeah, I have to see. That's a syntax change. With the device, I don't need that.
Right.
So now let's check syntax. And I do appreciate you being my second set of eyes.
Okay, this is one of those moments that every DBA and every developer gets into. You can stare at the trees for 10 minutes and you still can't see the forest. So let's... Good effort on troubleshooting here. Incorrect with...
I tell you what, how about if we just back it up with the GUI?
There you go. And then we'll script it out. How's that? So we're going to add in our device here, specifying the location in the GUI, and giving it a file name. Keep talking.
All righty. And now that I have the destination, I have my backup.
All right.
So now I'm going to change some data, back up the log.
Okay.
And then I'll have to back that up to a device as well.
So we're going to go back in, and again, using the GUI, this time we are going to choose a transaction log backup and specify the destination. We can either put it to the same file as it's set here, or we can send it to a different destination.
Yep. And notice that I'm going to append to the existing backup set that equates to the T-SQL option of with no init.
Okay.
So that means add to the current file. Make some more modifications. So next what I'm going to do, we'll take a look at the backup device that I made. And Rich, remind me, what was that?
D:/backups.
hc.back. Does that sound right?
We'll find out in a second, won't we?
We'll find out in a second.
When you go off the reservation with backups,
unscripted.
Yeah. It happens all the time.
Or is it from file equals?
Yep.
Is it warmer in here now?
It's getting hot.
Yeah.
That's what happens when you're under the spotlight and things are going south here.
I promise I looked at this.
Right-click, go to backups, find the device.
Sorry? Right-click
So
where?
if we go in, let's verify that file location first off.
Yeah, okay. So we have to go to Windows Explorer. No, that's of my local machine, not my virtual machine.
There it is. Yeah, D drive.
Well, isn't that curious?
We lost the file.
Well, actually, the folder didn't exist. I thought I had an automation procedure to make that so it wasn't made to begin with. Okay.
All right.
Let's try this for recovery now. Elise, I imagine we're getting some pretty funny comments.
Okay, so this just goes to show that no matter how long you've been doing things and no matter how many times you've done the same thing, yeah, it's called brainus interruptus. Okay?
My goodness.
And we'll give George a second here to kind of get things going.
Yeah.
But
I
really
think,
and truly, what we're talking about here is trying to look at the contents of the backup file to retrieve what's in there, right, George?
absolutely. So let's say I did use a command where I listed, this was going to be part of the punchline. I had maybe a couple of full backups. I had a couple differential backups intermingled with some log file backups. Now I need to find out what's in that file, when it was last taken, maybe the range of log sequence numbers to compare that with another log, another backup. All the good, juicy information that I would want to find. I need to be familiar with these verification statements. So we have restore verify only. I have to give away the end of the movie now. And what we'll find out is when I use restore verify only, if there's no problem, I get absolutely minimal feedback. It just says the backup is okay.
Okay.
So not much there. Now these others, if I want to get a look at maybe the subject line of the backup, I have restore header only. I can get facts on the particular items within the backup file, so files within files, file list only, and then also label only. They all give me slightly different overlapping information depending on what I happen to be seeking.
Okay.
So those are the verification statements that we planned on looking at. All right, that's good for that.
All right, and this also does bring up a little bit of a topic. You really, really do want to make sure that as you're going through your backups and setting them up, this is a good place to kind of throw in. When backups go bad, what do you need to do? You need to test them and make sure that they actually worked. And this is a good lesson on that one.
Very good object lesson indeed.
All right.
For our next topic, we're going to take a look at restores and recovery. So there's a process that's undertaken by the database engine during a restore. You want to be familiar with that. There are different kinds of restores, actually a pretty good laundry list of available restore options. You want to be familiar with those. There are restore statements in the same way that there were backup statements. And then, yes, system databases have special consideration as well. So one of the charters of the restoration process, and to back up just a little bit, if you have enough instances and databases, it's not if.
It's when.
It's when. And I was telling you the other day about a story that happened to me. Nobody likes paying their auto insurance, right? Nobody likes doing that mundane, the kind of work that you're not really congratulated for. But Something when my son was 2 possessed him to scratch all the way around my car.
Oh dear.
I kid you not. The auto insurance company decided to process a claim for it. I was grateful for that. But nonetheless, that's when you want it to matter, when you need the recovery part. And so backing up is great, but you're going to have to be able to actually perform restore. So we'll see that there's a process involved in the recovery process. Namely, I have to lay all of my backed up data on the file system, so the combination of full backups, differential, and log backups. After that, we're going to have all of our log data, and in the log data, for a running database, likely there will be transactions that were hardened to the log that were not completed. They need to be peeled out, and there are transactions in the log that were hardened but never got applied to the database, and they need to be rolled forward. So collectively, we refer to this as copy, redo, and undo. Now, from a big picture standpoint, there are a few general principles. First, you don't want to make the situation worse. So I guess that's just a general principle. Calm down. You might be found in a stressful situation. There's a situation where my server may be intact, but maybe my data file somehow has a problem. I lost the media or the LUN that it sits on. In that case, as long as the SQL Server service is running, you're able to capture all the way to the end of the log, the tail of the log we call it, which means you're going to want to back that up. That's going to be one of your early on procedures in the recovery process. And in fact, built into the product, if you don't attempt to back up the tail of the log, you will be barked at, and it will tell you have to override to do any other kind of behavior there.
Absolutely.
So now, what would be the normal series of restore events that you'd have? We see these at the bottom of the slide. I'm going to lay down my most recent full.
Okay.
Followed by my most recent differential.
All right.
Differentials are cumulative, so I only need my most recent one. Followed by the series of every log file since that differential, followed by the tail of the log.
So you've got all of those different actions, but what are the different ways that you can apply them? And what are the different combinations you can use? Are there different kinds of restore strategies that are available?
Yeah, sure. So if I have the simple recovery model, we looked at the fact that I have no log data to restore. So I'm only going to be able to restore either just a full backup, or full plus most recent differential if I incorporated that into my strategy. I will tell you, you're going to want to know the sequence of events and the series of the process for the exam well, definitely.
All right.
Now, if I have a full recovery, I have more to work with.
That's true.
So I have the full database that I have to lay down as what we call a baseline restore.
Okay.
After that, the most recent differential, and then a series of log files all the way till the end of the log, unless I want something fancy that we'll take a look at shortly.
All right.
I might have to restore a system database. So we have system database restores, and then some fancier or esoteric kinds of restores. If I have an advanced database design, I might need to restore just a single file or all the files in a particular file group. Now, an ultimate fancy, if my application is already architected for this, is that I can perform an online restore where I bring the database online file group by file group.
Now, wait a minute. If I hear the word online, I'm thinking it's available for people to use?
That's right. It's available in pieces on a file group by file group basis.
So you would have had to have backed it up file group by file group to start with, right?
It's very strange. I can actually back up the database in full and still do a file-based restore. I wouldn't usually do it that way. I would have probably performed a file-by-file backup, but I can actually do a per-file restore from a full backup. I've done this before.
Awesome. Awesome.
We also have a piecemeal restore, which is a smaller or more granular kind of restore. And then per page, if I happen to have page corruptions, that's an Enterprise Edition feature.
Wow. So just like with backups, there are options on the restore statement as well, yes?
Yep, so I not only have backup statements, of course, I have restore statements, I restore database, and I also restore log, each with typical options. I've listed some of those here. These are ones you'll definitely want to be familiar with. And in particular, when you take a look at restore log, notice that I can restore all the way to the end of the log, but I can also stop short of that particular point in time if I want to.
Does that take care of those so-called user-induced errors?
Yes. Yep. So as long as I have an idea of when the uh-oh occurred, then I can pick a point in time.
Awesome.
A little caveat, though, keep in mind the clock time on a system versus the watch that somebody's wearing versus real time. Those might not perfectly correlate. So if you think you're being very precise, you just might want to be careful about that.
Good tip, good tip. So what about the system databases? Do we have things that we need to be worried about there? Are there different approaches there as well?
Yep, the system databases require some special treatment. So in the worst case, let's say master is corrupt.
Okay.
I'm not going to have a running SQL server at that time. You'll know it.
Yeah, you'd get and go and try and start SQL and it's going to yell at you.
Yeah, you're going to know it. So in fact, what I need is basically a factory fresh, puny little master, just enough so that the SQL Server service will start. After it will start, then I can restore of course, I have a backup of master somewhere.
One would certainly hope so.
So I restore master, and then the rest of the planets will align. All right. Now, that's when master is corrupt. When master is not corrupt, then I just need to restore right over the top of it. Keep in mind that master is aware of all the instance level settings, instance level security. It's aware of every database that's on the instance, every data file, every database option that's set on every database. So it's particularly important.
So minimally, you should probably back up master whenever you do anything major for sure.
Yeah, I have.
And on a regular basis anyway.
I agree with both of those. I would have a routine process that would back up my system databases at least daily, so I have at least that. But then I'd want to have a knee-jerk reaction. Anytime I make an instance level change, I would have a job that I could run ad hoc, so related to our previous module, and that would back up the system databases and put that in some handy place.
What about Model, MSDB, TempDB, the other system databases? Are there any issues there that we should be aware of?
Sure. If model is corrupt, then SQL Server again will not start. So I would have to restore model from a backup. But as long as master or I lost my train of thought there.
Yeah, that would be the derailment. It happens.
Yeah, there we go.
So with model, then it's just like recovering a user database? Is that what you were trying to say?
And recovering MSDB, if it fails, then the agent service will not start. So I'm going to have to recover that in order to start the agent service.
And TempDB? What about TempDB? Is there anything there?
No, there's nothing there. Why not?
Well, I don't know. You tell me.
The TempDB is rebuilt every single time that the instance is started, so you'll never incorporate that as part of your backup strategy.
All right. So can we go take a look at the restores?
Yeah, let's take a look.
We venture off into demo land once again.
Let's see, what do we have up for this? Okay.
Let's see what happens.
So let me make sure I have a folder that will accommodate our backups first.
All righty.
Let's see how this goes, Rich. We'll be up for a little bit of excitement, make a couple of devices.
You always wonder if the next one's going to break the trend.
Yeah, all right. So I'm going to make a database, make some stuff in the database.
Okay.
Perform some changes. So I'm just going to, so notice, create a bunch of columns. They have some default values.
Tables and back it up. Yep.
So next, back up my database in full. I'm going to run this one alone before I run the rest of them. You know, that's a whole lot better, isn't it?
I like seeing that backup statement work.
Yeah, so then run some modifications, back up the log, and then I'm going to fast forward through a bunch of the rest of them.
So basically, to sum it up, we're making changes to the database, adding data, modifying data, capturing the work through the backup log statements.
That's right. So more changes, back up the log, more changes, back up the log, lots of changes.
Okay.
Then back up the database, notice with differential.
Okay, so the backup logs are capturing the work, the differential is capturing the data that's changed.
In fact, with the differential backup, notice the option I used to select that. It only marks the extents in the data file that have any particular change. This is kind of a play on statistics.
Okay.
What I mean by that is within a database, there are often hot spots. So those tables that get the most action, that might be the biggest. So statistically, if only those extents that have changes occur within the differential backup, then that's hopefully not going to be anywhere near as much data compared to a full backup.
So differentials typically you would use when you've got a small percentage of the database that's having the greatest percentage of changes done to it.
A lot of action.
Okay.
Now, another advantage with the differential is that if I have aggressive log backups, let's say every 10 minutes, every 15, every 30, something like that. Picture maybe the requirement to restore from 10 in the morning all the way to 6 p.m. That's an awful lot of log restores in that circumstance. And I have a general rule of thumb, as you know I often do.
Yep.
Whatever, reduce the amount of moving parts. Keep low the number of moving parts. And what I mean by that is the number of restore operations you want to minimize.
Absolutely.
Okay, so what did I just do there? So now I have some more inserts, backup log. Let me just go to the bottom of this. Another differential, more log backups, and then we have to get to the exciting conclusion.
And here we come.
All right.
So can we take a look at the contents of the device?
All right, so now I can go to media contents, and there's actually stuff there. I would probably want to expand these, but lots of useful information. Now, this is a pretty version of what I could also get by querying tables in MSDB, so keep that in mind.
Okay.
All right. This part I'm going to use for the restore stuff. So that concludes the part on backing up.
Restore. So
Did I
let's
misspeak?
take a look at the restore part of it now.
Yeah.
So keep right on trucking there with it, George.
Oh, you know what? I'm supposed to show that now. What do you know?
Yep, we got the backup working finally, so let's finish up with the restore now.
Okay, so I want you to observe if I refresh the databases node and look at the manufacturing database, it looks like any old regular database.
Okay.
So let's say something comes to my attention, maybe somebody can't query that database within that database, and I realize I had a media failure.
All right.
So now I can go ahead and back up the tail of the log.
Capturing everything that happened since the last backup.
All right, and it would probably help if I actually ran all my code and used master.
There we go.
All righty, and after a refresh, I'd like you to make an observation. Notice this has kicked the database in the side and immediately placed it into a restoring state.
Okay.
And I want you to see something wonderful here. Notice if I were to use the GUI and go to do a restore, it shows all of the elements that I would need to bring it up to the moment of, all the way to the end of the log.
So it does all of the telling you what needs to be restored based on the history tables.
Yeah, in fact, it shows that I need the most recent full, most recent differential, not all the differentials,
Yep.
and then of course all the logs that I'd need. Now, as bonus round, notice if I go to, let's see, I'm missing some of the user interface here. I'm looking for the point in time recovery.
Main page.
Do-do-do-do-do.
And that's going to be...
Oh, you know what? That might be. Let's see.
Yep.
Oh, timeline. Duh.
Right there in front of our nose.
Come on. All right, so from timeline here, notice I have the ability to restore not all the way to the end of the log file. That was the punchline.
There you go.
So we have a slider. We can use a specific date and time. In fact, you can use a date time value to go to milliseconds if you had that degree of detail. All right, so that wraps up the backup and restoration portion.
All right, so the next topic we're talking about here comes up when you have a situation where you want to move a database from one instance to another or something along those lines.
Yeah, I have a dynamic environment, especially if I have a pile of SQL servers. I might need to move a database to balance load. That's one possible reason. I might want to put a copy of a database somewhere else. That's a possibility. From a workload standpoint, I might want to balance the workload on a particular LUN and just move one data file or move a log file. Maybe I add storage and I now want to move a file to that. So that's what we'll take a look at next, moving databases and database files. And we'll find there's a division here, once again, between normal user databases and system databases.
Oh, you got to treat the system databases special. What a great idea.
All right, so moving and copying databases to other instances, multiple techniques, no surprise. We've seen this all along in the SQL Server product.
Yep.
We can use Management Studio. When in doubt, I'm going to right-click. So I can right-click on a database and perform a process called detaching it. Now, to compare something, if I were to right-click on a database and delete it,
yeah, that would scare the heck out of me.
the files are gone, completely gone.
Makes our last topic kind of important.
If I merely detach a database, the files are still in the file system, but the SQL Server instance no longer has any claws or any hooks on them. And in fact, I could rename them, delete them, do whatever I want. They're just dumb files in the file system then. Whereas the data files, when the database is attached, I cannot touch them. I cannot rename them, move them, nothing, which is why this procedure is relevant. So after I detach, I then would move one or more of the files, and then I would attach. That's the general procedure name. In contrast to using Management Studio, SSMS, I can use SP detach DB, and I can also move or copy databases using SQL Server Integration Services. There are specific tasks for that, but I can't talk too much about that. That's your thunder for Friday.
Oh, you mean you want people to come back?
Oh, yeah.
That would be cool.
Yeah, I got to dangle some hooks or some carrots out there for that. There's a
we
lot
go.
of fun stuff there on Friday. I'm looking forward to Friday. So, as a newer procedure, using the SP attach DB, which has existed for a good long time, is being discouraged, and now create database with some additional syntax elements, and the for attach clause is now being promoted as the way to attach.
Awesome.
As with a number of file maintenance and file manipulation operations, I have to use the logical file names, but what if I don't know what they are?
Let me guess, you can query a
catalog
view.
Of course, I have catalog views that will reveal everything like that. So let's move on. Take a look at relocating database files within a single instance. So if I want to move a database from one instance to another, I'll have to detach, and then I can attach. But what if I just want to relocate one file within an instance? Well, I use alter database for that, and no surprise, it will require the use of logical file names. So,
okay, and once you've done, you have to actually move the files too.
Well, yeah, and then I have to move the files in the file system and point properly.
That makes sense. So what about the system databases?
Yep, they need some special treatment. In particular, master, if I, for whatever reason that I would decide to move it, I'm going to have to use a special startup option. So I'll have to go into SQL Server Configuration Manager. You can look up the gory detail as long as you know you need a special switch. Is it -M?
Yeah.
I think it's -M, but whatever, some startup switch, and then you'll restart the SQL Server service. Other system databases, they'll also require alter database, but you'll have to restart the SQL Server service. So with that, let's take a look at moving a user database.
So are we going to move it between instances this time, George?
you know what? I don't even remember off the top of my head.
Yeah.
I have something. I have something squared away.
All right. So
first, I'm going to make a database in the default instance. So the default instance I've connected to down here, and I'm going to create a database called DB2BMoved.
I love your naming.
Don't you?
It actually tells me what you're going to do with it.
All right, so we happen to see this having been created in the graphical user interface. I see it here right now. So from here, I can go ahead and detach it. Now, I suppose it would be a little more dramatic if I tried to rename those files, drop them while the database is attached. It's not going to work. But for right now, I'll click on OK and notice this is no longer part of the default instance.
Now, it didn't delete the files. It just disconnected it from the instance.
And in fact, we're going to see this because now what I want to do is attach that database to another instance, whether this is halfway around the planet or, you know, another machine in the rack. That's immaterial.
Okay.
The process is the same. So let me go to Windows Explorer, and I have to move a couple of things.
All righty.
Let me get my taskbar here, and we'll find in the default instance, here is my database to be moved. The other instance is in the marketing folder. Now that's my data file. Next up, I'm going to have to go to
the log
L.
file in the L drive.
There we go. L, and we'll take my log file and we'll move it to marketing as well. All right. Next up, let's go to the non-default instance, right-click on databases, and let's attach. Let's point to our new file location, db2bmoved, and observe with the log file, it thinks, well, it's actually thumbprinted in the file where it thinks it's supposed to be, and guess what?
It's not there anymore.
Its cheese was moved, so
All right.
we have to point appropriately. So now we have to go to the log file location, and here is db2bmoved. Click on OK, and there it is.
And we are back in business. Very cool.
All right, let's see if I had any other fun. Let's call that good for now.
All right, so our next topic, George, we're going to be talking about something that really has a lot to do with the backups and restores, database integrity.
Yeah, it's not likely that the database engine will ever, or I should say, it's not likely that databases are corrupted. But before you back up a database that you don't want to back up a database that's corrupted.
No.
You'd like to find out if it's corrupted and then maybe proceed in a maintenance routine through the backup process. So we have to take a look in general at ensuring database integrity. And this is going to involve the use of some DBCC statements. This would be part of your normal maintenance routine, like we saw maintenance routines in an earlier module today. So we're going to take a look at DBCC in general and then specifically related to integrity checking statements.
Okay.
How we execute it, and in the rare and unfortunate event that it reports errors, what we're going to do about it.
Oh dear. So what is DBCC after all?
So first of all, it's the name, or the the acronym starts for Database Console Command. This is a new version of the acronym. Formerly, it was Database Easy for me to say, Database Consistency Checker. And now, as you can see, or as you would see from the link, there are lots of DBCC statements.
Okay.
The time when a database might become corrupt would not so much be likely with the SQL Server system, but with the I/O system. Maybe I have a corrupt caching controller or host bus adapter, something like that. Now, some of the statements that we'll see in DBCC, they're categorized. We have informational statements, validation statements, maintenance, etc. So there are lots of those. It'd probably be a good tour of duty to at least become basically familiar with some of them.
DBCC can be an extremely useful tool when you're looking at the databases.
So the one that we're going to look at now, let's go to the next slide, is DBCC Check DB. and its purpose is to validate integrity of the database structure and the data inside it. Strangely, it actually spawns other processes, other DBCC statements like check allocations, check table, and DBCC check catalog.
Okay.
If I have a large database whose integrity I'm attempting to check, there are some options I might want to consider, namely because it might take seriously hours and hours and hours to run this. So notice some of the options that we have: physical only, no index, all error messages. This might be if I just want to see error messages. I don't care about all the detailed reporting that it can provide if I want. And another one, estimate only. So just give me an estimate
of what it would take.
Next up, in the rare circumstance where a database would have corruption, we have repair options. And this part is easy. There are only two. The other part that's easy is if there's corruption that's reported, it will state what the minimum required repair option of the two is in order to fix something.
So it'll tell you what you need to run.
It will tell you what you need to run. Now, my database is going to have to be in single user mode, and I'll use, as we saw earlier, that's a database availability option. I'll have to go to alter database to put that in single user mode.
Okay.
And now for the two options that I have, repair, rebuild. Notice no loss of data integrity within the database, and it does some shuffling under the covers to put the database back in good order. Now, very unfortunate. If you are advised to use the repair allow data loss option, this is absolutely the last resort. This is if you have no backups, absolutely out of altitude and ideas, as they say. This is your only choice. Picture a gun to your head. You have no other choice, and then that's when you're going to pick that.
All right.
Now, after you perform your operation, you're going to want to make sure that it doesn't occur again. So you're going to have to aim at getting to the root cause.
Okay. Can you show us how it's done, George?
Yeah, let's take a look at using DBCC CheckDB and some of the things that it reports.
All right.
And let me make sure I'm connected to the right instance. So I'll run DBCC CheckDB targeted at a particular database, and you'll notice
there's a lot of messages there.
It's somewhat verbose. Lots and lots and lots of stuff here.
So I got to read through all that to find out if my database is all set?
This is kind of like the boss that says, I'm thinking of Elise here, just give me the facts, please. Are we okay? So you'll notice at the end it says, Elise is here in the room. She's managing our project here. Notice it says 0 allocation errors, 0 consistency errors. So it took all that to get to that conclusion.
Okay, tell me, George, is there a less verbose way of doing it?
Let's take a look at running DBCC with no info messages.
That would be a good one.
So we'll run that. Notice this database is not particularly large, and what did we get? Yep, you're okay. Yep, you're okay.
All right.
All right, now I have a problem child. Let's see.
Okay.
I want to make sure my path is right here.
All right.
So we have SQL admin jump starts.
Got that one in the wrong spot, huh?
Did I put that on F? Okay, well that was an easy
that's
fix.
an easy change. Change it from D to F.
Okay. Let's see if that dog will bark.
There we go.
All right. You've been a patient guy with me, Rich.
I tried, George. I tried.
You know you got to be, though.
That's probably because I've been there, done that, got the T-shirt on these things once or twice myself. Hey, wait a minute. There's red ink.
Ooh, red ink can be bad.
Hey.
So we observe down below there are errors.
Okay.
No allocation errors, but there are consistency errors, and it got worse than that, not in red. What's my only available fix here?
Repair allow data loss.
Now, strangely, how might someone even become acquainted with this? Well, I might perform a query, and notice I'm doing a select star. So all columns, all rows. This is going to retrieve every page in the table. Ew.
Logical consistency based? Yowza.
Yeah, so let's say an error like this is reported from an end user. They're going to call help desk, tech support, something like that. Somehow that's going to get to the data team. But take a look at this. Notice, depending on where the query is made, there might be unaffected areas of the same table.
So some of the data is good, some of the data is not.
Yep, and just a little, this is a little ad hoc here, Rich. Let's say I selected star from MSDB dot, I think it's DBO suspect pages. Ooh, on target. This would also show up to 1,000 corrupted pages, pages where the checksum didn't match the data that was read.
That's one of those tables you'd really want to keep an eye on over time.
And strangely, the product is set to only store 1,000 rows of suspect pages. I think that's reasonable.
If you don't have that many.
If you had anywhere near 1,000 pages, you have bigger problems. All right, so next, alter database, set single user with rollback immediate. Oh, here we go over the waterfall, Rich.
And we're doing that because we restored a corrupt backup. So that kind of gets rid of restore, doesn't it?
We lost all altitude and ideas. We had absolutely no other choice but to repair. So now, let's go ahead and put the database back in production, so to say. Notice we can query the table now. We at least don't get an error. And notice that, well, our integrity has been maintained. The only thing is, though, it paid no attention to foreign key references, which means this shows all the order details that are no longer associated with orders. Basically, we are in seriously hurting shape.
So we lost data.
We lost data.
Now,
all right, that's the end of that
kind
one.
of is expected with repair allow data loss.
Yeah.
All right, so what about other maintenance that we do? Are there things that we want to be aware of and things we want to take care of?
Yep, last topic for this particular session is dealing with indexes, statistics, maintenance. So we have to take a look at a couple of table structures that are out there, indexes, and then some other objects and their maintenance. So with that up, let's go to table structures. If I were to create a table in SQL Server without any special options, we would see that A, the data is stored in pages as normal, but the pages are in no particular order within the data file.
Okay.
In addition, the rows within those pages are in no particular order.
Okay, so it's just a heap of data.
Just a heap of data. Now,
all right.
Often, for various query improvement purposes, we will want to impose not only an order of rows within a page, but a logical order from page to page.
Okay.
And then some extra pages are stored outside of that clustered table that are used to navigate and find those objects.
Okay.
All right, so now that we know what the two table structures are, we have to take a look at what our indexing options are. There are various ways that we want to query data in SQL Server, and we have objects to make sure that those queries are efficient, index objects. Now, an index is just a list of sorted values. Let's keep it simple. And as an add-on, that list of values may impose uniqueness or it may not. I often find that the constraints that are used to make indexes are confused with the index names. So to help you along the way, I've made a little matrix here of the different kinds of constraints and indexes and how they map.
So what do we need to be aware of with indexes other than the fact that they help us look stuff up?
Invariably, over time, data is going to change and indexes are going to get fragmented. So that's going to impose upon us, the database administration team, to maintain those indexes. And we'll see a couple of ways that we're able to do that. Now, before I get there, well, there's another object we want to talk about, and that is statistics.
What does statistics do for you?
First of all, statistics are objects that basically compute the estimated number of rows or actually calculate the number of rows in a table. And this can be important for the query optimizer when it goes to produce a query execution plan. It may impact the join order of one table to another based on the number of rows in one table compared to another. And also, statistics will gather things like, if I'm querying for the name Smith, I might have 10,000 Smiths. If I'm querying for a Squillace, I might only have one, and that may impact the query execution plan.
Okay.
So statistics are valuable objects is the big picture here.
All right.
Now, some good news, if I can cut over to my virtual machine for a moment, let's take a look at the model database. And if I go to the model database, we'll notice under options, there are a couple of options here. Let's use green. First of all, we have the auto create statistics option, and we have the auto update statistics option. Now, on smaller databases, and I don't mean puny, but on something that's not gargantuan, these are fine to leave on. There are some that have some very strong opinions on whether or not these should be on, and for the largest databases, you'll probably want to have a background automation process to have those updated or create and update them. The impact here is that if I make a new database, it will have the same settings as model.
Okay.
So now that we know that, let's go back. Let's go back to our regular slide, if you would please. And we see that statistics can also become outdated as data changes. So we now have laid on the table that there are indexes to maintain and statistics to maintain, which brings us to the topic of index fragmentation.
Okay, and what's fragmentation all about?
There are two kinds of fragmentation that can occur in indexed and tabled data. So we have internal and external fragmentation. Internal fragmentation is kind of like this. Let's say I have a little kiddie pool of water.
Okay.
And I have a bucket that I want to use to carry the water from one place to another. If I only fill the bucket up halfway, I have to make double the number of trips.
Makes sense.
This is like a page of data that's only half full. SQL Server is going to have to read the page into memory in order to use it for querying, which means it's taking up twice the amount of space that it needs to, and it's more I/O operations to get the pages in. So often I don't want this. However, if I know I have lots of rows that I'm going to be adding in, then I may want to have pages partially full. And there's a percentage that I can use to dictate that called fill factor. Now, external pages relates to the physical location of pages within a data file, and when they're spread out, the read-write head of the spindle is going to have to move. Anytime the read-write head has to unnecessarily move, that is a negative performance impact, and you don't want that. Now,
so how do you now get the maintenance to trigger off? How do you actually execute that maintenance?
Alrighty, well, one of the things that you'll want to do is you may have a particular table that seems to be performing poorly. So one of the things that I may do, let's say I go to our market dev database, pick a particular table, and let's say I go to a particular index, I can get properties on that.
Okay.
Now, this is when I would have the foreknowledge or concern about a particular index out of maybe 10,000 that I have in the instances that I operate. And notice that I can see the fragmentation here and the page fullness.
Okay.
General threshold. If I see a number above 30%, I'll want to perform one operation. If I'm maybe 10 to 30%, I'll want to perform another operation.
Okay.
So with that,
what are those operations that we want to do?
yeah, those operations, I wanted to go back to the slide for just a second. I showed how you could use the GUI, and this is the index fragmentation page. So I think that's back one. Perfect. So at the bottom, you'll notice I can use the graphical user interface to determine fragmentation, and also I have a dynamic management object. Some of those we looked at early on. This is a very broad-reaching DMF. Notice that I can look database-wide across all indexes in the instance to determine fragmentation, and more granular than that. Okay, let's go on then. And then finally, notice that I have automation steps that I can use to maintain indexes. For indexes, I can reorganize them, which is more of a shuffling and modest efficiency improvement, modestly improving of fragmentation. And then rebuild actually takes space to completely recreate the index and then collapses the old one and replaces with a brand new rebuilt index. Rebuilding takes more time. Enterprise Edition has some online versions of the maintenance operations. And a curious thing, when I reorganize an index, if I cancel that in the middle, the work that's been done up to that moment is retained. If I cancel a rebuild, well, it never made it to the finish line. That I'm not able to use.
Oh, that's too bad.
You'll notice from the graphic on the slide also, I'm using the SSIS version of the maintenance task. Notice I can rebuild an index, reorganize, and I also can update statistics. These are very granular.
So rebuild and reorganize are exclusive to each other. You wouldn't do one and then the other.
No.
You'd do one or the other.
That's right. So what I might do is first have a query that looks for those objects which have a certain threshold of fragmentation and reorganize those. And completely separate, look for those objects that have a greater threshold of fragmentation, and then I would rebuild those.
All right.
I do want to go on record saying there are lots of very polar ideas about what the proper thresholds are, how often you should do this, whether or not you should even bother doing that. So do a little bit of research there. And now the final thing, let's see, you want to see this last one?
I think we can do this last demo, absolutely.
Okay, I think it's pretty quick, but let's see.
So in this one, we're going to go and after we've already looked at the fragmentation, as you did in your last little demo, now we're going to actually do some maintenance on an index, George.
Oh, you know what? Oh, yeah, here we go.
All right, so what do we got going on here?
All right, so I'm going to create a table in TempDB, and I'm going to populate it with some data.
Okay.
Next up, the population. So we're going to put 10,000 rows in this.
And hopefully that one doesn't take too long. Boy, that's good. SQL's quick. I like that.
All right, next, let's check the level of fragmentation using a dynamic management object and notice the number of inputs that this function can take, and notice options like detailed.
All righty. So we've got a clustered index on the table, and it's telling us what, George?
All right, so now I see the average fragmentation in percent at the moment.
Okay.
And another one of particular importance is the average page space used. Notice it can't be more full than 100%, so it's fairly jammed packed.
I'd say 99 point something is pretty doggone good.
Now, there's some fun query code written here to scramble everything around and fragment the heck out of the data that's within that particular table.
Okay.
So this time around, we'll now query using the same dynamic management object, but observe now the fragmentation in percent.
Yeah, boy.
And let's also take a look at the average page space used. Notice much less used. Now, one of my maintenance options is to use alter index all, and that says on behalf of a table object that I have, I'm going to rebuild all indexes.
Okay.
So,
that went pretty quick, so I would say that was a pretty small table.
Pretty small table. So now let's go ahead and determine if there is any fragmentation that remains after a rebuild. You probably can predict the end of the movie, right?
Yeah,
so
let's hope so.
Average fragmentation in percent, 0.
Awesome.
All right, and then average page space used in percent, there we go.
Back up to that
full.
Good level. Very cool.
All right, so in this session, we took a look at data file maintenance, other kinds of maintenance, data stewardship, and next up is security.
Yeah, we will be back in just about 10 minutes. Thanks very much. See you in a few. Welcome back to the Administering SQL Server 2012 Jump Start. I'm Rich Curry. This is Mr. George Squillace. We have the geeks in the background that are helping us out. Thanks to the geeks. Yeah, without them, you would not be seeing this. So absolutely, absolutely thanks to the guys behind the camera.
All right.
George, what do we got coming up now?
So look, Rich, we're 4 modules down already, kind of unbelievable, but this module, again, a very important module, something that you just have to get right. Remember, it's your fault.
It always is my fault. Just ask Elise, she'll tell you.
So implementing security, a bunch of topics to look at, and going to the overview, we have onion layers, I suppose we could describe, onion layers of security that we could set in SQL Server. And we want to take a look at each one of those layers. Okay, I'll use the proper term, scopes of security. We have server level scope, database level scope. We want to investigate the levels of security that we have, server level, database level, and then some strategies that we'll use for implementing permissions. That's the big picture for this particular module.
So let's start up at the top. What do you think?
Sure. So in this particular topic, we'll look at, in general, the security scopes, list them by name, give you a picture to have in mind that will help you put your mind around what the available scopes are, and then look at some other things, authentication modes, and then allowing someone to access a SQL Server instance. Then we'll take a look at some administrative activities at the instance. So that's coming up.
All right.
Big picture. The point of the diagram is to show that there are security options, or there is security that can be applied at several different scopes. Up at the instance, and you see some example objects that can be controlled that are instance level objects. Then we have database scope objects, schema scope within a database, and ultimately, and most granular, we have individual objects within a database that can be controlled.
So could you talk about scope as kind of like a container? So the database scope is inside the server scope and the schema scope is inside the database scope?
Yep, think Rolling Stone. And
okay.
Not so much in the sense of the music, but if I happen to assign permissions at one scope, generally speaking, and depending on the permission, those permissions are going to roll downhill, bless you, roll downhill to the other scopes. There are some permission-specific statements that you'll see. I like, in particular, in one of the courses that I teach, where it talks about the grant statement, and it says something like, quote, "The grant statement is a very complex statement. There are a lot of options, but at least the point is obvious. We're giving access to something."
All right.
So moving along, one of the first important security decisions that needs to be made is the authentication mode. As you can see from the lower right, this decision can be made during installation and can also be changed after the fact. So it's a little bit tiny, but you'll see 2 radio buttons which permits solely Windows authenticated access to SQL Server, alternately Windows plus SQL Server logins.
So basically, you can always use your Windows identity to log in, but SQL Server logins have to be specified specifically.
Got to throw a switch on, and there's a cost.
Uh-oh, what's the cost?
The cost is that you're going to have to restart the instance, restart the database service after you make that change.
So anytime you change security, you got to restart the instance.
Well, anytime you change that in particular, for sure.
Authentication, yeah. Okay.
Now, for those that have a lot of SQL servers, consider this. What actually changes is a registry key, which means then if you wanted to change the mode universally on a bunch of SQL servers, you could actually set up group policy to change the registry key in the policy and apply that to your fleet of SQL servers, restart them, and you are good to go.
Very cool, very cool.
You'll notice with a Windows identity, that's something that's already defined in Windows, but if you go back for just a second, in the upper right, we're seeing that we could create a SQL login, which is thumbprinted, so to say, to this particular SQL server. Quick little side note, starting with, I think this was SQL 2005, you now can have SQL logins pay attention to the underlying Windows password policy if it's a server operating system.
Yep. You set it in AD, and then SQL Server follows along.
Yep. So let's move on to login objects. And this slide caters to those that might be newer to SQL Server. And I'm trying to make it very obvious how someone ultimately gains access to objects within SQL Server. Think of it as clearing 3 separate hurdles. First, I have to knock at the front door and furnish identity of who I am.
Okay.
And not only do I have to prove who I am, but then I have to show that I'm invited to the party.
Okay.
So we refer to this as authentication and authorization. Now think about this. If you go in, this is a sort of a private question, but let's say you go into one of your friends' houses. You going to wander around and look inside the medicine cabinet?
I hope not.
No. So similarly, once I get through the front door of the SQL Server, I may not be able to wander around everywhere in the instance. And we'll see from the second hurdle, my login object, which is created to permit access into SQL Server, must then be registered at the database level. To back up for just a sec, notice that logins can be derived from a few different sources, a Windows account or a SQL Server account, and they also can involve Windows groups.
Okay. Why would you use a group instead of individual accounts?
Well, it has to do a little bit with, we'll just say, turf war. If I want Windows administrators to manage groups, then I could pass that off and let them populate, but generally it's a measure of efficiency.
Okay.
So that's a good point to bring up. Now, at the second hurdle, I have user objects that are then registered at each and every database where I want to log in to be able to do something. Similarly, just because I can enter through the front door of a database doesn't give me access to everything within that database. And this brings us to the third hurdle. This will be what we'll look at towards the end of this module, actually gaining access to objects within a database. And there are a few different strategies that you can use for this. Now, when it comes to the tools that I'll use to build all this, yes, like a lot of things we've seen, I have the graphical user interface.
Absolutely.
Like we've seen before, I have code-based methods, create, login, alter, drop, etc.
Yep.
There we go. And along with these login objects, they have configurable options.
All
Not a
right.
lot of options, but some. All right, so next up, let's take a look at administrative capabilities at the instance level. So we'll refer to these as server level roles, server level permissions. Now, think of being on a cruise ship.
Okay.
So being on a cruise ship, boy, you would really not want to fall from one of those cruise ships because a cruise ship isn't going to be able to stop on a dime. It's not going to really be able to turn on a dime either.
Hope you can swim.
So the comparison here is that there are certain things that have been part of the SQL Server product that have been around for a long time and they're hard to let go of.
Okay.
And in particular, I'm referring to server-based roles. Sometimes they're called fixed server roles, namely because I can't change their name, I can't change their permissions. The one thing I could do is add or remove members.
Okay.
Drum roll, please. We have some product excitement.
Uh-oh. Something new?
Something new. Now in SQL 2012, finally, we have the ability to create our own server-based roles. You'll get to see this coming up in a moment.
Party favors and cheers, please.
There you go. All right.
DBAs have been screaming for that one for a long time.
Yeah, namely because often the fixed server roles granted a whole lot more than you would normally want to for any particular purpose, so that really made them null and void. So in order to create both server roles and to be able to assign more granular server level permissions, we have a few tools that apply. Any surprises? We have Management Studio.
I would hope so.
Well, we also have a system stored procedure if I want to use code to add a member of a role and if I want to create a role. So you see those two code elements there.
So would it be safe to say then that if you don't want to assign specific permissions to a user, you create a user-defined role and assign the permissions?
Yeah, good strategy.
Awesome.
All right, so guys, if you'd cut over to my virtual machine.
Let's go take a gander.
I'll collapse a few things to tidy up. and we'll focus at the instance level here. So notice I have the security node, and under the security node I have server roles. These would be what we would consider as fixed database roles. Now, having been with the product for a long time, I recognize these names. These are all fixed roles. Not a single role is a non-default role. These are all default roles, so to say.
Okay.
So with the graphical user interface, I now am able to create a new server level role. So let's call this administer logins.
All right.
And now I'm able to grant access to the particular logins that I might want to grant access to, whoever those might be. So I have one selected. I could grant the control permission. And of course, I'm able to script out almost any graphical user interface activity and put all of that in code. So now that I've created the name of the role, the permissions of the role, this is where I would determine who the members of the role are, and now I could add members.
Just as an aside, that script button, that is a great way to record the stuff that you're doing to your database, to your instance, so that when you try and go back and figure it out 2 days later, you can actually remember it.
Yeah, are you a record-keeping kind of a person?
When it comes to databases, I am.
Yep, all right. Alrighty, so next up, I'm going to create a couple of logins, and as I'm able to create a login with the graphical user interface, you'll see that I can also create logins in code. And you'll observe from the names here, these are not Windows naming conventions. A Windows naming convention would require a machine name, or more likely a domain name, a backslash, and then a name, which means that these are SQL logins.
Okay. And what are those options that you've got set on there, like default database and check policy?
Yeah, so I think I skipped this, pointing this out on a slide before. I had a little picture of a laser pointer on one of the slides and skipped stating what the relevance of that was. When a user successfully connects through the front door of a SQL server, they are always, repeat after me, always pointed at a particular database. So using the default database option says when someone comes through the front door, their laser pointer, so to say, is pointed at that particular database. Now you can move your laser pointer with the use database statement, but this sets up a default option. And also, you can determine whether you want a SQL login to forcefully adhere to Windows password policy or not. When you do, that seriously raises the security and safety of SQL logins.
So that would be like password expiration and complexity, things like that?
Perfect. I'm glad you brought those out.
Awesome.
So I can't remember if I ran this or not. Okay, I didn't. Otherwise, I would have had an error. And with the refresh, notice I have a bunch more objects. So at this point, I would be able to go to the instance. Let me just look at a couple of those names. Like, okay, Bob and Brandy. Go to properties. Go to properties of the instance. Go to permissions. Now I see the list of logins. So let's say Brandy, we want to grant her, instead of membership in a role, maybe she's a developer and we want to grant her create any database. So grant create any database with Brandy being selected.
Awesome.
Now, maybe Jane needs more authority than that, and once Jane is selected, now I assign her grant control server. There's a general principle I want to bring out about create any database, and that is if I have the ability to create something and I exercise that privilege, then I own the object I created, and if I own it, that's supreme. I have ultimate control over it.
Awesome.
All right, so that shows how to create a server-based role, how to create logins, and how to assign them privileges. And now in code, you'll see how I can create a server role in code. Now grant a permission to that particular server level role, and now add a member to that role.
Neat.
I want to give you guys a little phrase here that might help you out. Principals are assigned permissions to securables. A principal being something that can be granted access, a securable being something that is protectable within the system. And then a permission ties them together. All right, I think that was all that I had for that one. Just server scope permission. So I also have server scope permissions, grant control on login, grant create any database. So that's a code-based version of what we saw.
Okay.
And then a connect permission.
So if you've got server level security set up, does that automatically give you permissions and abilities to act within a database?
No. So what we've just looked at is clearing the first hurdle, both in the sense of getting into the instance with a login and then having administrative privileges at the instance. We're now going to echo that, but at the database scope. So we'll take a look at getting access within a particular database and then administering a database as well. So we'll see in this topic, we'll look at creating database users from logins. We'll take a look at database level roles and a nifty trick, something you may be familiar with, maybe not, called application roles. So off to database users.
All right. So what is a database user? How do they work?
A database user represents the second hurdle of the three hurdles in my picture, and we see that in order to gain access to a particular database, my login at the instance level needs to be registered at the database level. I could have an instance with 50 or 100 databases, but I might have only access to one. So whatever databases I need access to, I'm going to have my login registered at the database level in the form of a user object. Now, I may want to divide the responsibility of administering a particular database, and in that case, I also have database level roles. Similar to the instance level, there have always been fixed database level roles. They're called fixed for the same reasons.
Okay.
Can't change their name, can't change their permissions, but I can change membership.
All right.
Also similar to this server level, in general, they give away more privileges than I would want to, so we'll often have an alternate technique for granting administrative privileges. This would be solved in the form of a user-defined database role. All right, now application roles. I explicitly described those actually in a slide or two, so we'll get to that in a moment.
So can we talk a little bit more about those database level roles, George?
Yeah, so you'll see from the screen capture here, I can, let's see. I had to see, just getting my bearings there. So I selected
It's been a long day.
Yeah, been a long day. In fact, if you guys will cut over to my machine, I think I'd rather just show this. So I'm going to navigate to a particular database, expand the database, go to security, and from a confusion standpoint, notice that I have security at the instance level, but each database also has its own security node. I think this can be confusing at times for those that are new to the product. So when I go to roles, I have database roles, and once again, this represents my fixed set of database roles.
Okay.
I also have users defined, and if I want to have a user registered at this particular database, so that would be the fancy DB, when in doubt, I'm going to right-click. I'm going to choose to create a new user, and from here, I'll define the classification of user that I want. A SQL user with a login, we'll talk about this shortly, or a Windows user. Okay. Notice the form changes based on my choice. If I have a Windows user, I'm going to obviously have to pick the location of that Windows user and then either grab a group or I'm going to have to grab a Windows user.
Okay.
All right. Or I could grab a SQL login, and in this case,
You give it a username,
I'm
right?
going to have to go ahead and pick what particular login it is. And this is where I'll see the laundry list of logins that I made. I don't know why I picked more than one, so I only wanted to pick one. All right, so that's how I would create a database level user.
Okay.
Except, notice the foil there.
You need to have a username.
Yeah, this is, even though this is derived, whoops, I lost my mic there for a sec. Even though this is derived from a Windows login name, strangely, the name doesn't have to match at the database level.
That's a good thing.
Yeah, this could be a good thing because I could have something like a lengthy or obtuse Windows group name and maybe make a friendlier name within the database system. But for right now, I'm just going to do a quick copy and paste, make that easy.
So if it makes sense for traceability and being able to track back through, it probably makes sense to name the username and the login the same thing most often.
You know, I think so. I'm kind of Captain Straightforward, and I think, honestly, as I age, I like straightforward more and more.
All right.
All right, next up, and I kind of jumped ahead to our demonstration since it was convenient, but
That's all right. We talk about it while we're doing it.
so now going to database roles, notice I can create a new database role. This particular part of the feature has been around as long as I've worked with SQL Server, so at least all the way back to SQL 2000 and probably way before that as well. So I would identify pools of people either administratively or within the database that need some access, and I would come up with a name that represents the kind of access that they need. So something like healthcare table access.
So really what we're talking about is people that serve the same function rather than have the same identity.
Exactly. So after I make a role, that would be one of the legs of this. I should say after I create a name, then of course I'm going to have to add one or more members. And notice the members that I can add here fall within these classes. Either users, so logins registered at the database level, or strangely, I can nest a database role within another database role. Be careful about over-engineering that, though. All right, so let's go ahead and add, even if it's only one person. Now, the final part of this story, I can't give this away just yet, is assigning permissions to the role. That we're going to take a look at a little bit later.
All right. So what about application roles, George? Are database level roles and application level roles the same thing?
No, in fact, let's go ahead and cut back over to my virtual machine for a second. See, there are some smarty pantses out there, and some of the smarty pantses have connected some dots.
Okay.
They'll say something like, well, hey, I can use this application. It connects to a particular database. Maybe somebody gave them some details. They know what the server name is. Maybe they even know some of the objects they would access. So they could do something like this. In fact, I don't even remember if I have Office on this machine, but let's say we did.
Hey, we got one.
So now I could go ahead and make a connection directly to a SQL server. And if it was based on my Windows or SQL credentials, I'd be able to make a connection and manipulate objects completely outside of the application's logic.
Wait a minute. Are you trying to say to me that a user who's got access through an application, if I create their username, they can come in some other way and still get at the data?
At the moment.
Oh, dear.
Yep. So one of two things is true, Rich. That's the way that I want it, or that's not the way that I want it.
So what if I don't want it that way?
So if that's not the way that I want it, I actually have a control. Let me go ahead and get out of this first. I like to think of Superman when I think of application roles, and here's why. What you want to picture is someone going through a telephone booth. Clark Kent, let's say. He goes through as one identity and comes out as a new identity. Generally speaking, something with more privileges.
Okay.
So in that case, I can set up an application role, which we'll observe involves creating a name. Let's call this pharmacy access.
Okay.
And you'll notice the elements or the building blocks here. Just like, no, that's smooth. Okay, just like with a regular database role, it has a name. So,
Okay.
And just like a database role, it has securables or those things that I want to assign permissions to.
Okay.
What's different is this part. Whoops, this part.
All right. That's got a password.
Yeah, so notice this has a password, and notice it does not have members.
I was looking at that and I was wondering, how does somebody use the role if you don't have membership?
So let me just put in a dummy password here so that I'm able to complete the creation of this object.
Okay.
And that will be the activation password. So let me go back, if you go back to the slides for a moment there, troopers.
All righty.
Now, what I need is my front-end application. I'm sorry, I have to back up. So I'm a human, and I open up an application. I open up a web URL. I open up a Windows application. That application is going to have code behind to make a connection to the database.
Okay.
From there, it will bear my credentials in interacting with the database, except if I have an application role, I have a statement that says this connection is going into the telephone booth and coming out as somebody different, but the end user does not know that this happened. They neither know the role name, nor do they know the activation password that I just set up.
So SQL's not giving permission or allowing access based on who they are, but rather by code telling them what they can do.
Exactly. So only based on what their role dictates will they have access, which means then if Smarty Pants user would now attempt to use Excel and attempt to make a connection to the database, that they wouldn't have any permissions because they would be assigned to the application role. So there we go. All right,
awesome.
And that's going to take care of our demo coming up of us implementing database level security.
So the last piece of this then is really going to be permissions.
Yep, so now we have object permissions, or implementing permissions, object permissions, code and module permissions, and we have to get to some permissions management strategies.
Okay. Let's take a look then at object permissions.
All right. So I have a broad class of objects that are contained within a database. We have tables, views. You see there are a bunch of other objects there. Object permissions apply to those particular objects. Now, there's a phrase that I used earlier. If I have to do something once,
I'm probably going to need to do it more than once.
Probably going to have to do it again. So I would tend to want to avoid giving permissions to single objects, and when I can, leverage a better strategy. Meaning, if Susie needs access to table 1, then she's probably going to need access to table 2 or a broader base of objects. So that means now I'm managing access on an object-by-object basis. So the other thing is, Susie may be here today, but she may go, and that means now I'm going to have to take Patty or Mikey or somebody else and assign them all the same security that Susie had.
Okay.
So let's see if there might be a way that we can improve efficiency there. As far as object permissions are concerned, it depends on the type of object. So I might need to change the structure of something like a table. Maybe I need to add a column, add a constraint. So alter permissions might apply. Another possible permission is broad control, where I have really unrestricted access to a particular object. Now, for objects that hold data, such as a table, we have data manipulation language statements that we can execute, select permission, insert, etc. And then finally, what I call the tattletale permission.
The tattletale.
I might want someone to be able to look at the code that defined an object, but not have them change the definition of the object. That's a minimalist permission. So we have the view definition permission.
Awesome. Now, are objects the only things that you can set permissions on, or are there other things that we're going to need to deal with?
In addition to objects like tables and that, we also have executable T-SQL code objects, such as stored procedures and certain kinds of functions.
Okay.
So they also have permissions that apply to them. Some overlap, but not a perfect overlap. The primary permissions that apply on a code module would be the execute permission to use it. So if I wanted to use a stored procedure, execute it within code, I would need, well, the execute permission.
Okay. So how do you set up these permissions? How do you get them to applied so that you can manage everything?
Sure. Consistent within SQL Server, we have Management Studio. And within Management Studio, I can start with a principal. That is, let's say Mary needs permissions. I can get properties on Mary and then point her to the particular securable. Alternately, I can go to the securable and then bring principals that I want to assign permissions. So it kind of depends on, well, somewhat preference, but also if I need to assign a principal to multiple objects, start with a principal. If I have a securable that needs multiple principal assignments, start with a securable.
Okay.
So there's no crime either way. You can get the job done.
All right.
Now, if I want to do it in T-SQL code, I have my normal DCL statements, data control language statements, grant, revoke, and deny. Should we talk about those for a minute?
Absolutely. I think
right.
they're important.
So when I have this nice candy bar, thanks Microsoft, I saw that out in the hallway here. Let's consider this as a precious resource of some kind, and it is a good one too.
Okay.
All right. Let's consider this is some precious resource that I have. If I want to extend that to someone else, I use the grant statement.
If I eat this now, that's going to cause you problems, right?
Now, let's say I had provided something to Rich and I no longer want it to be that way. I can take it back. That would be a revoke statement. There's another circumstance, and that is when, well, Rich, you're right next to me. I'm going to pick on you.
Okay.
Let's say you're a member of a role. So you're a member of a role. Let's say it's the sales role, and I grant you access to a particular table. I grant the group access to a table. And maybe that group is granted access to a number of different tables.
Okay.
But there's one particular table the group has access to that I don't want you to have access to.
Are you picking on me?
Absolutely. And in this case, I'm kind of at a fork in the road.
Okay.
Neither road will be easy. One road is to create another group with the same sales members except you.
Okay.
And that means now I have to manage two separate groups and remember when to use which one. This is not tidy.
All right.
Perhaps the path of lesser evil is to keep you in the group, assign the group permissions to the table the group needs, and then I explicitly assign you the deny permission. So that's one way that may reduce my overall effort of administration, but you have to do that sparingly. That can make your troubleshooting somewhat more difficult.
So you can either let me do it by saying you're granting it to me, or you can tell me, no, you can't do it by denying me.
Exactly. And there's one more kind of strangeness. Let's say that I gave you a negative. I gave you a deny.
Okay.
I can actually use the revoke statement to remove the negative.
Oh.
So keep in mind, removing a negative is also performed with the revoke statement.
So grant makes an entry, deny makes an entry, revoke removes an entry.
Good observation, good point to make.
Nice.
And then finally, there is a security anomaly that's been fixed in SQL Server 2012. This
goes back a long way too.
Goes back a long way. But prior to when I was working with the product, it's been in there as long as I've known. Namely, I can have a table level deny and a column level grant that will succeed. I didn't really talk about column level grant, so you're learning two things here. First, yes, column level grant has been around in the product for a while where I grant just certain columns. But the anomaly of a column level grant overriding a table level deny no longer exists. Everybody say ah. All right.
All right, so what about the strategies? How do we apply all this stuff? What are some approaches we can take?
All right, I'm going to take pain somewhere.
Usually.
So it's just a matter of where I want pane, and normally it's always better to take pane up front.
Okay.
And I coined a term here. I'm going to be famous for this someday. Double abstraction, and I want to tell you what I mean by this. We're going to review a couple different ways to implement permissions. Ultimately, here's my phrase. You want to make sure that you design so that the design works hard for you rather than make you work hard.
Makes sense.
So at the far left here, we see that we could have a couple of database objects and use our database user objects and directly grant them access to those objects. The thing is, maybe one of those is Bill. Bill might come and go, so now I have to remove Bill, and then I'm going to have to add Susie and grant her access to all those objects all over again.
Okay.
Remember, the work stays pretty much the same, but the worker changes.
Yep.
So I can improve this a little bit in the next model if I use something like a Windows group. So at least a Windows group will have members, although I'm still taking the group and directly assigning them access to objects. Still maybe not the greatest idea.
But the odds of getting rid of a group are probably less than getting rid of an individual user.
Absolutely. So this is definitely an improvement.
Okay.
Now, even better is using a database or an application role, and I've used them interchangeably for this particular purpose. Again, the work is going to stay pretty much the same. The workers will change. So I can create a semi-fixed relationship of assigning permissions from a role to one or more objects, and then just manage membership. So this is where you want to aim. You want to aim for managing membership and not doing all the granular permission changing.
That way you assign the permissions one time, and then you just add people in and out instead of having to keep changing the permissions.
Exactly.
I like that.
And in the next model, I raised this just a little bit by using Windows groups that are added to database roles. Now, in fact, I skipped a little detail. You don't add a Windows group to a role. You would have a login defined from a Windows group. Then that's registered at the user level, which is then made a member of a database role. Okay,
now,
so then...
that makes a lot of sense, but what about permissions at the object level? I mean, is there a way to group things there?
In fact, what we see, this is the drum roll, big conclusion, thank you very much. We'll find that all objects are contained within schemas, at least certain data accessible objects, stored procedures, tables, views, etc. They're contained within a schema. The fancy part is that we can use schemas to collect objects that need uniform permissions, like a bunch of stored procedures that a pool of people need to execute, or a bunch of tables where people need to select and insert into, not delete, not update. So I can pull those objects inside a schema, grant permissions to the schema. Now, in this case, I get easy for me to say, I get double abstraction. So on one end, I can add or remove objects to the schema and not have to assign permissions to them. Because the permission was assigned to the schema, I don't need to worry about permissions to the individual object. So I add another stored procedure, it needs execute, great. Now the other end of double abstraction, instead of having to assign permissions, when I get a new Mikey, a new Sheila, I just add them as a member of the role. So I have abstraction on both sides of the permission equation, and Rich, you're excited about it.
I'm absolutely over the top. I can't wait to see it, actually.
All right, so
how about it?
Let's move on to that.
All right, let's go take a look at the demo. And in this one, we're going to be playing with those permissions that we were just talking about.
All right, so let's go ahead and create, let's see, I made a database role. And next up, let's go ahead and create a schema object.
Okay.
So let's say I create a new schema. We'll call this the manufacturing schema.
I like that.
Do you?
Yeah, it means we're making something.
All right. All right, now let's see. I have to look at what database I was in. So I was in the fancy database. Let me make sure I'm pointed to the fancy database. And now we'll create just a couple of objects, create table, and we'll get the schema name. T1 for table 1. Just make something sort of silly.
Yep.
Execute that.
Easy table.
All right, next up, we'll make another table. Actually, this time, let's create a procedure. We'll call it P1 for proc1. As select star from manufacturing .t1.
Okay. So we've
right?
got a table, we've got a procedure.
We've
What's
got a table
next?
and we've got a procedure. Okay, so now using, of course, both the GUI or code, I'm going to take my role and assign it to the schema. Which way do you
Okay.
want to start from, the role or the schema?
Oh, surprise me, George.
Okay, so let's start at the schema. I'll go to Properties. We'll go to Permissions,
Okay.
and this is where I will assign a database level principal, a user, or a role.
Okay.
So on one end, we have the abstraction of objects being in the schema. That's already been set up. But now, let's go ahead and pick a role. So object types, we see database level objects, and now let's pick the particular one. All right, pick whatever role we want. The one we're picking isn't material to the demonstration,
All
just
right.
by virtue of picking a role.
Okay.
And so now I have the 3 legs of the permission stool, so to say. I have the securable, that's the schema object and the items in it. I have the principal, and now we have to combine those in here, and grant a permission. So let's say we have grant execute for stored procedures, and grant insert and select for tables. Whoops, it comes lower in the alphabet.
It has been a long day, hasn't it?
Alrighty.
I'm having trouble remembering my alphabet, too.
There you
Don't
go.
worry.
Alrighty. We have a few minutes left with this session. Can I take a little bit of liberty here, Elise?
Yeah, go
okay.
for it.
There are a few resources that I want to direct people to. In particular, some websites that have email subscriptions. They'll send some stuff daily to you in your inbox. So at the expense of piling up a little bit of mail, I've been immensely benefited by being a subscriber to some of these. So in some form of follow-up, we'll make sure we get this. We'll make sure we get this to you. But to list them by name, here are some of my favorites. First, MSSQLtips.com, a great one. So MSSQL Tips, there are lots of contributors, lots of real smarty pantses that contribute there. Another one, SQLServerCentral.com. Pretty parallel sites in terms of what they offer, email-based subscriptions, tips, code, lots of great stuff. Another one, these are from, these two are, at least one is a former Microsoft employee, and they live here in Seattle metro area. This is Paul S. Randall and Kimberly Tripp's, their group, SQLskills.com. An interesting thing, Paul Randall is a big book reader, and he'll often tell you what he's reading. He reads some crazy stuff. So when I say crazy, I mean a broad variety. That's pretty nifty. So thanks for putting up the web URLs. And then a couple of other things. Rich, would you add up SQLSaturday.com? There are SQL Saturday free one-day training events.
If I can spell Saturday, I'll be
yeah.
happy to.
All over the planet. And I got to put in a little plug for SQL Saturday Kalamazoo, Michigan, coming up in November. You know,
That would be that one right there, huh, George?
you know what? We'll have people come from Chicago, Ohio, all over Michigan, and there's some real smarty pantses that work hard and contribute a lot to that event. This will be my 3rd SQL Saturday Kalamazoo. Great, maybe my 4th, but really good stuff.
And I just want to point out that these are not just events that are here in the U.S. As you can see from the listing here, Lima, Peru, Ancona, Italy, Slovenia. So, no matter where you're viewing this from, check this out because there may be an event that's pretty close to you and you can get the benefits from it as well.
Two more if I can.
Uh-oh.
For, you know what, I think we'll save one for the BI one, Pragmatic Works. We'll wait on them. But
Okay.
one more, go to SQLpass.org if you would, please.
SQLpass.org.
SQLpass.org. So this is the laundry list of pass-oriented user groups all around. Somewhere on there, see Find a Local Chapter? It's in the upper right.
Okay.
Or towards the right.
There we go.
So find a
if it
local
were any
chapter.
bigger, it would have hit me.
Danny, what state did you grow up in?
Illinois.
Okay, so let's do pass region, United States,
There's
Canada, U.S. Let's see, Illinois, so Midwest Heartland, I think is what they call it.
Okay.
Pick one, it doesn't matter, and just search.
All right.
So I can pretty much guarantee if you're anywhere near a major city, there are going to be some past chapters nearby.
Awesome.
I've benefited a lot from being involved. See, in Michigan, you show where you live by holding up your hand. I'm right smack dab in mid-Michigan, so I'm not far from Grand Rapids, a little more than an hour, not far from Detroit, a little more than an hour. So I'll participate in both user groups, and most recently I was able to speak in our Detroit user group. A lot of fun there.
And again, just want to point out that as with the last website we showed you, there are lots of international chapters available as well. I just very quickly pulled up some of the Asia Pacific chapters. There are others in Latin America and Europe as well. So again, great resource, and being able to connect with folks that have the same interests, the same professional responsibilities can be invaluable. So
Yep, good stuff. All right, so that concludes this particular segment. One more segment left, and
that
definitely
would be it.
an important and a very interesting segment, something I've put a lot of time and enthusiasm into, and that's high availability. So we're going to take a short break, and after that, session 6 of 6.
Oh my goodness, we're coming to the end. Oh no, I'm disappointed. See you back here at top of the hour. Welcome back, Module 6, our final one of the day. I am Rich Curry, still and will continue to be. George Squillace, still and will continue to be. George, what do we got coming to end things up today?
An interesting and a really vital topic to a SQL database administrator, the topic of high availability. A bunch of different things to take a look at within high availability. We'll first have to take a look at what high availability is and the particular kinds of things that it covers, and then we're going to drill down into a number of different high availability technologies.
All right, so
Now, I want to be clear, a couple of these are really not covered on the exam whatsoever. That's not so much the relevance, like, for example, replication. Not really covered at all on the exam, but because the topic is high availability, I want all of you to have a decent big picture look at the availability options that are within the product. So I'll have an inclusion of all those, at least a little bit, for your sake, not so much for exam purposes.
So let's start out. What is high availability all about, George?
When I'm trying to protect my environment, I need duplication at some level or levels. So high availability refers to having something available after some form of failure.
So if a machine crashes or if a disk file breaks, disk
Exactly.
drive breaks, something along those lines.
So I could have media failures, I could have complete server failures, I could have complete data center failures. There are failures really at a number of different catastrophic levels. So we have different kinds of high availability technologies. Some protect against hardware. Well, one in particular, failover clustering, or what I'll call traditional failover clustering, protects against hardware failure. I have a lot more to talk about there, so we'll save the more detailed explanation until later. Okay. Now, in particular, there are multiple technologies that protect against media failure, the loss of a database file, a LUN, things like that. And so we'll see that all of these involve duplicating database data, the entire database, or a portion of a database somehow.
Okay, so what's the first one that we want to talk about?
Okay, so the first one we want to take a look at is replication. And what you want to picture here is Grandpa's old cottage. This is something that's been around for a long time. It's tried and true. It's loved. It's useful. To tell you the truth, though, replication's a handful. It's very highly configurable, and there are a lot of ways that you can architect it. Rich, you know you're in trouble when you go to look up books on replication and you see that any of the books, that there are only a couple books available on it,
Yep.
but they're over 500 pages. Simple Talk is coming up with a free ebook on replication. Should be out any time now.
That's a good thing, because I don't care what you're doing. Replication, at some level, you're probably going to have to deal with it in your SQL Server career.
And not only that, but it's probably going to get tangled at some particular point, and you're going to have to learn how to untangle it as well. Now, every one of the topic areas in this module is going to have a general pattern, like what are the facts, the basic technology that it uses, or movement or duplication method. Then, what are the hands-on or general hands-on processes for implementing it? And then, not a single one of the technologies is perfect. Every one has something glaring that's omitting, or some potential drawback. And that's even true with the very newest technology, which has a lot to love, and that's always-on technology. So let's get busy and take a look at replication.
So let's start out with the basics. What's replication all about?
Okay, replication allows me to identify objects within a database, specific objects, which we call articles.
Okay.
These could be things like tables, even a filtered table where I have a portion of columns, a portion of rows. So we'll refer to that as a portion of an object or a whole object. And I have a collection of articles that are then contained within a publication.
So kind of like a magazine and the articles in a magazine.
Yeah, and then that is made available to one or more SQL servers. So the machine which is making the data available is a publisher. The machine which is consuming it is a subscriber.
Okay.
And in a more elaborate architecture, there will be a role somewhere on the publisher, on the subscriber, or maybe even on a separate box that is doing the data movement, and that's called the distributor.
So kind of like the U.S. Postal Service sometimes.
Sure. The distributor can be on any one of those machines, and in a larger environment, I might have a dedicated distributor.
Okay.
Now, as far as data distribution, that's part of what this is all about, data duplication, data distribution. You're going to see a graph on the slide here which illustrates a balancing act. So we have autonomy versus latency. Now, there are times where I might have a copy of a database or a copy of an article, and I want it transactionally very consistent, not perfect, very consistent with the original object. And notice that moves us towards very low latency, but if we happen to lose a connection between the two machines that are replicating, then we have no autonomy, so we're going to have a problem.
So very little time for them to have to be in the difference between them, very little time to make them the same again, but there's a high dependency between each other.
Exactly. Now, on the opposite end, we have very high latency that allows maybe a lack of connectivity for an extended period of time, but no worries. Maybe I don't need the latest data. So we have other ways of being able to handle that. High autonomy, but also with high latency. Now, I don't need you to memorize all the terms in between the two extremes. Just realize you have a lot of choices.
Oh, yeah.
There are a lot of ways to weave this, and I have a lot of respect for those that wrote the code to get all of this to work.
In one of my previous lives, George, I had 120 databases that we were synchronizing data with, going through with replication in different levels, and I got to tell you, it was a lot of work. It is a great technology that requires a lot of attention.
Okay. Now, I've already stated what some of the possible articles are. I could have a complete or filtered table, but there's some other objects, such as a stored procedure that produces rows, a view. Now, a curiosity is that whenever I pick an object with dependencies, like a view or a stored procedure, the underlying objects come along with it.
Okay.
Whether you have to select those two. So in the process of configuring a replication, I have to determine a schedule for how frequently I will want the propagated updates to go to the target or subscriber. And in this case, agent services are going to have to communicate with other agent services. So whether you use code or the graphical user interface, you're going to have to configure agent security. These are the basics of replication.
So what are the broad types of replication available?
You'll see on the next slide that there are a number of different replication types, and I've shown you one of the wizard steps involved in setting up a replicated set of objects if you use the wizard. So we have snapshot, transactional, and merge. Those are the broad types, and notice we have two different kinds of transactional replication. So with snapshot, I'll have a large amount of changes, maybe let's say 80% of the data in an article changes from cycle to cycle. So rather than tracking the individual changes moment by moment, we just take everything wrapped up in the publication and replicating it.
So it would be like taking a picture of your kid once a week and replacing it in the frame.
Exactly. That's a good analogy. Now, on the opposite end, merge replication would be like, if you're familiar with domain controllers, I might have 3 different Active Directory domain controllers, each holding full copies of the object. And if an object changes in one copy, then that's going to change in the other copies as well. Transactional replication would be when I have some modification, I want that more immediately reflected in a destination. And like I said, there are many configurable options with this.
So how do I implement that? What are the different steps that go into it?
Well, taking a look at implementing replication, there are lots of things to like when it comes to high availability, because I'm duplicating data. You'll notice it can support not only one subscriber, but I can have multiple subscribers for one publication. So I can have even more than one copy.
So I could take data from one spot and send it out to a whole bunch of different servers.
A bunch of different servers anywhere on my network. So this could be geographically distributed. That's what I'm trying to point out in the lower right part of the diagram. So different IP subnets, different SQL servers, even in different data centers. Now, there's no automatic failover. So if I'm pointing an application to some data on one machine and it fails, there's absolutely nothing that causes or redirects a client. This would be an entirely manual process, and it depends on how the application makes a connection. If you can point to a different IP address or change the connection string of the application, that would dictate in part how you would perform failover. So there are shared folders where replicated updates are stored. The distributor will pick them up there and then move them along. Lots and lots of moving parts here.
Cool.
So let's take a look at the strengths and weaknesses. A strength, replication's been around for a long time. So it's tried and true. You've said you've used it
Absolutely.
a lot. Lots of configurability. I don't need any specialty hardware, so I can have completely different hardware configurations. One is a publisher, one is a subscriber. As long as it can handle the workload, that's fine. I can span data centers, which covers a catastrophic data center loss. And I can have multiple secondary copies. And depending on the replication method that I use, they also can be locally modified and the changes replicated back.
But what about weaknesses? What are the things that might keep you from choosing?
They all have a price, right?
Absolutely,
So
everything does.
we saw no manual client failover, and in fact, depending on how my application makes a connection to SQL Server, that could really be a handful. So
Sure.
you need to look at that for your own environment. Also, this is not really a system data kind of protection. This is for user data, or user database data. And unless you select every single table in your database, it's only partial database protection.
Okay.
And by the way, you're not going to likely select every table for replication.
No.
Tell me your own opinion. Just so I'm looking for an opinion here. Have you ever gotten replication really tangled up and it really caused some snarls to get it back up and running?
Frequently, one of the things that we ran into was when you had a problem with replication, just about the only choice in some cases was to delete it and start it all over again.
So you killed the subscription and started over. Yeah, I've heard of this as a plan of attack. Do we call it?
Yeah, one of the things that is highly recommended with replication is that when you do set it up and configure it, that you script out the replication and save those scripts, because that will make it a lot easier.
Excellent. Good piece of advice. All right, so next up, if you guys would flip to my screen, we'll take a look at how we would walk through the publication creating process. So I'm connected in Management Studio. You'll notice there's a replication node, and from there I can choose New Publication. No surprise, I get to a wizard, it welcomes me, and from there I have to dictate where the distributor in this architecture will be. So with this particular architecture, I'm saying that the publisher will also be the distributor. Remember, lots of different choices there. So after that, we'll find that there has to be a folder designated where updates can be found that the distributor will pick up on and then move to a target location. So if there are enormous amounts of updates or you have a number of subscribers making connections, you might want to make sure that you specify a place that has enough space. Now, another thing to keep in mind compared to our other technologies, all of this occurs within a single database. So notice, as far as the scope of protection, we're actually inside the boundaries of the database. So I have to pick the database within which I want to replicate, and then this should look a little bit familiar.
Yeah, I saw that one earlier.
Now, think about this. There are certain doors you go through in life. The door slams behind you, and there's no knob on your side.
Okay.
And similarly, when we change the publication type, that's a door we don't go back through. There are several other choices. You step in a bear trap. You have to rip the subscription or publication out in order to make a change.
So once you've set it, that's about it. Okay.
You're going to have to stick with that.
All right.
All right. So next up, this is important. You'll see this is the list of articles. You guys got to go back to my slide. Thanks. You have to pick from within the boundaries of available articles. So you can read. We have tables, stored procedures. But notice that we have the plus signs next to a couple of the objects.
So we can expand those and see the individuals on each one.
And in fact, on a column by stinking column basis.
So you don't even have to do a whole table.
That's right. So I don't have to do all columns, but in addition, let me get up to this next part, I also can filter by rows. So seriously, what if I have a table that has a bunch of data from a bunch of regions, and I only want the the American region or North American region? So I can essentially write a where clause here, and from the where clause determine only that data which I want.
That is pretty cool.
Granularity is the big deal here. Now, there is a potential to have more than one subscriber. We saw that as a strong point. So after we've configured this, we have a place where an additional subscriber can go to pick up changes, and also on an ongoing basis for those current subscribers. And now I'm at the snapshot agent, which sets up on what regularity will a publication or will a replication cycle occur. So this is going to end up creating an agent job and use the normal agent job and scheduling process.
So a snapshot is only going to update when the agent tells it to.
Exactly.
Okay.
And for agent security, depending on what particular type of replication I'm going to use, I'll have to make an association of the agent in one instance to the agent in another instance. I just wanted to see that, not necessarily all the gory detail. Now, towards the end of the wizard, notice it asks me, do I just want a script, but I don't want to do it?
Okay.
Do I want to create the publication, but not script, or what Mr. Safety would do?
Absolutely, you do them both.
I'm going to do both. And from there, it asks me more questions. Basically, how do I want to create the script file? So, do I want to append the new script file to an existing? Maybe I have a whole batch of replication script code that I want to have, and a couple of other options there. And then finally, complete the wizard. I name my publication, and then it gives me a status update.
Awesome, George.
There you go. So after that, I would then see in the list of publications, I would see a publication.
Awesome. Awesome. So replication, all about getting data from point A to point B. It's more about the movement of the data than it is about everything else, right?
Yeah, and also the fact that I can very carefully control the type of data and the frequency that I want to send it. So I think replication really isn't considered a pure high availability technology, but it's duplicating data.
So if I move one step closer then, and I want a database to be more tightly coupled to its replica, what would I do there?
Well, let's take a look at the next technology, log shipping. Again, log shipping is a tried and true technology. Let's go to the next slide. We'll take a look at the big picture here. So we have the same pattern that we'll look at for log shipping that we did in the other, or in replication and the other technologies too. The basics, how we put it together, how failover works, and a strength and weakness comparison. Now, if you'll go back for just a second, one of the things that you'll see here in the screenshot, I've gotten properties on a particular database, and you'll notice at the bottom we have log shipping as one of the pages. What is the key place to get that started? Well, of course, enabling it. So let's go on to the basics, and I want you to focus on the diagram here. We'll say that right now I have SQL Server 1 in the upper left, and it's serving the production copy of a database.
Okay.
So I have maybe a web app, a Windows app that's used to make a connection to that, and so I'll have clients on a network probably close to that machine.
Okay.
So now I run through the log shipping configuration, and a bunch of moving parts are put in place. First of all, this primarily applies to user databases, but the entire database, its schema, and its data. So this is clearly a high availability technology.
So no longer do we have the ability to choose individual objects to filter out data. It's all or nothing here.
Yeah, it's all or nothing. So as I walk through the wizard, first I create a schedule that says, take the transaction log of the current database, back it up generally pretty frequently, and then store those transaction logs in a shared folder, preferably that's nearby.
So does that schedule for the transaction log backup, does that drive the latency between the two databases?
Definitely. And in fact, before we get done, we'll see there are several schedules that can be carefully crafted so that you get exactly the latency that you want. And this can very much work in your favor. Hold on to that thought for a second.
Hanging on, baby.
Right. So next part of the wizard, we have to determine on what level of frequency we'll take the backed up transaction logs close to another shared folder that may be in the same data center, on a different SQL server, on a completely different subnet, completely different area of the network, meaning a different geographical location. As long as the SQL agent can connect to UNC share, it's reachable. So in the worst of cases, we could have a data center failure, and as long as all our mission critical databases were log shipped to another destination, all that data's there. Everybody say, ah.
Ah.
We're not done yet though, Rich, because
there's more.
Now we have a third schedule, and the third schedule, and by the way, these can all have different time frames. That's part of the point.
Okay.
So I can back up, let's say, every 10 minutes, take those backups every hour in one folder, copy them to another folder, and then the third schedule basically does a perpetual mini restore. So it keeps the transaction logs restored over the top of the destination database or databases because I can actually have more than one copy of a logship database. That's good news.
Absolutely.
And in fact, this is strategic. I could actually have different restore schedules, maybe one aggressive and one not aggressive, so it could account for maybe a DB, I have maybe a 4-hour delay with one logship copy, and in that case, it's not going to receive an error for hours based on that. That may help me position well in a recovery situation.
That's pretty cool. Now, is the recovery the only thing that you can use log shipping for, or are there other things that you can do with a logship database?
Well, one point to bring out is that with the database there's a setting that says what is going to be important, allowing read-only querying of the destination log shipped copy or the backup job, the restore job. So one of those is going to win. So let's picture something.
Okay.
Let's say I have a connected user that's read-only querying a logship copy.
Okay.
One of two things is going to win when the next restore schedule comes up. Either the user that's connected in querying is going to be allowed to win and continue querying until he or she is good and done, or the backup job says, honey, I'm home, boom, comes in, does the restore, kicks out the connected user. So which one are you going to pick?
It depends.
Excellent. That's the answer to every consultant's question. You fell into that trap perfectly. Alrighty, so that's the essence of log shipping. Lots to like about it. So now that we take a look at log shipping, let's go to implementing it. So I can configure this in Management Studio. You'll see an example of this coming up. And there are lots of stored procedures that can weave all of this together. I didn't mention this. I think there are over 100 stored procedures just related to replication.
So
whatever, a whole bunch.
So let me guess. Given a choice, I'd want Management Studio to use its wizardry.
Ba-doom.
All right, so it's late in the afternoon. I apologize. Keep going.
No. So I can use, as a matter of fact, if I script the whole process out, these are the stored procedures that I'm going to see.
Awesome.
I have to have a recovery model that can use the log file, and more than likely this is going to be the full recovery model. And so looking at the architecture diagram, we see that a backup job is going to have to be created, multiple copy jobs, or I should say a copy job, and then restore jobs to perpetually restore the database. There is an optional architectural element called a monitor server, which can be queryable, and it doesn't need to be any fancy addition either. I can have that as part of the architecture too.
And what does the monitor server give you?
Why don't you run with that one? How's that for tossing the hot football?
Okay, so you're going to put me on the hot spot. So the monitor server is going to watch the process, and then if it fails, if the primary fails, it's going to help me fail over?
No, it's not going to help me fail over. It's really more of a tattletale object, honestly. So there is no manual failover whatsoever with log shipping. And in fact, let's go over to failover basics where we can take a look at this. So if I have a failure, it depends on what happens to the source. If I have a catastrophic server loss, well, that's going to I sure don't have any transaction log data there to grab.
Nope.
So if I happen to have a problem where maybe the machine is still available, but the SQL Server service is not running, or there's some damage to the database, at least grab those most recently backed up transaction logs and copy them near to where I want to recover. So back up the primary database log with no recovery. That's going to capture the tail of the log too.
Okay.
So I'm going to bring all of that data over, and I'm going to perform a normal database recovery on the destination. It's going to have some jobs associated with being a secondary. Disable all of those. You may want to leave that or turn it back on later. So don't kill the jobs.
Okay.
Just disable them. And then what you may want to do is to establish high availability at the destination. You're going to want to configure log shipping on that machine. But what do you do with clients?
You got me on that one, George.
So a couple things that you could do with clients. It depends on how the application is architected. So if the application has a connection string that points to an IP address, well, you can change the IP address of the destination. That's one way. Another way you could do it is if your application connection string points to a DNS name. Well, you can change the IP address in DNS, and then clients are redirected transparently as well. So there's not a perfect transactional failover while somebody's using the logship machine, but those are some of the failover options. So notice, totally manual intervention, but there's opportunity for being graceful.
And for log shipping, just like with replication, there are strengths and weaknesses, right?
So strengths, it's been around forever. It's
That's
mature.
a good thing.
A lot of people know how to use it, which means you might be able to get help untangling it. You have multiple copy jobs and restore jobs with their own schedules, so I can have more than one copy, and like I mentioned before, maybe one aggressive log ship copy doing a perpetual restore, maybe only a few minutes behind the original server, the production server, and maybe another copy that's a few hours behind, just to help. It's not, as you'll see from the demonstration, not too difficult to initially configure or manage, and no specialty hardware. That's
a good thing.
Now, because copy jobs can move from UNC path to UNC path, this means anywhere in my network where I have access, I could even span geographical regions.
Okay.
My secondary database is read-only queryable based on how I have that set up. And alert jobs can be set up if a replication cycle doesn't occur. I said the R word. If I have a failed job, either in restoring or comping, and it doesn't occur within a certain threshold, I get an alert. Everybody say, ah.
And what about the weaknesses? What are the things we need to look out for?
So manual failover as described. This also has to be configured on a per database basis so it doesn't protect the entire instance. And it can't protect master. So you're not going to put, you're not going to turn the full recovery model on master. So that is in, what would you say, unprotectable database?
Yeah,
we'll go with that.
Like it.
Okay, so let's take a look at log shipping. If you guys will zip to my machine for a sec. Actually, hold on for just a sec.
Yeah, you were a little bit late on that call there, George.
Okay. All right. So taking a look, I'm looking at properties of a database, and the point to focus on is the recovery model. I have to have something that has logged transactions that are not going to be overwritten like in the simple recovery model. Now from there, I'm going to go to the transaction log shipping page, properties of the database, and after I'm in the right recovery model, what do you think I'm going to do?
That checkbox that's sitting there staring at me looks like a good place to start.
So that's like kicking off the domino chain. After I click on enable, a whole bunch of action occurs. So enable this as a primary database. This will be the production database copy. And then I would click on backup settings. I really don't need to look at that. That's just going to set up a job with a schedule. Okay. So that's really business, excuse me, business as usual.
Squeaky over here doing the demo.
Yep, squeaky squillace. So transaction log backup settings. So transaction log backups are performed by an agent job running on the primary. I'm going to have a place, a shared folder where I'm going to place my backed up transaction logs.
And that's where the partner servers can go and grab it from.
Yeah, now I actually could do this two ways. I could have one folder for storing the logs and then copying those to another folder nearby, or I could actually specify that they're the same folder.
Okay.
So consultant, how are you going to pick?
Let's see. It depends.
It depends. I would say if they're geographically distributed, I would pick different folders.
Okay.
If they're in the same data center, then maybe, big deal. What does it matter that they're different?
It's probably going to be the same server anyway. They're going to have easy access.
Lots of controls here, so I can delete transaction logs that are older than a certain time, get an alert if no backup occurs within. If I want to carefully have naming conventions for these related jobs, fine, I can do all that. So after that, let's see. I think I just did that. So let's go here. So again, business as usual, job schedule. Sorry, didn't need to go there. Okay, next up, I now have the secondary database settings. Now I have to point to the instance where I want to have this database, and the database names don't actually have to match. Please, Rich, keep it straightforward. Have the same database names, and this would seem to make sense, but now I'm in the first tab, initialize the secondary database. Do I want Management Studio to restore a backup? So I may already have a database copy there. Maybe it's already there. Or I can actually set up the process right here and now.
Okay.
So after that, so did I jump ahead here? Let me see.
No. So you set up the database, you set up the destination, you're specifying the locations, right?
Yep, so specify locations. If the secondary database will be created when the backup is restored, specify the place for data and log file. So
okay,
that's if it didn't already exist. So next up, I'm in the middle tab, copy file. So this is where I could specify a second folder if I wanted to, or point to the original folder where I had my backup jobs.
Okay.
My normal inclination is to have separate locations. And if anybody has a lot of experience with this and has a strong feeling on the matter, it might be interesting to see what some of the posts are there. But I set up a UNC path here, and again, delete copies after a certain threshold of time, have a copy job name, set up the schedule. So all that, of course, is independently configurable as well. So we don't really need to look at schedule. Now, finally, we're on the last part of the configuration, and you'll see two radio buttons there, which answers the question, what's going to win? Do I want users that are querying the database to have precedence, or do I want the restore jobs to have precedence and cut out those connected read-only users? Notice I have delay restoring backups at least a certain amount of time, alert if no restore occurs within, and then again a job name.
So the three pieces are, how often do you want to back it up and where do you want to put the backups? How often do you want to copy them and where are you going to copy them to? And then how often do you want to restore and will you let people query it?
Excellent summary. And so finally, if I wanted to monitor server, yeah, I'd have to go through some of the same configuration there. How I'm going to have the agents talk to each other, which instance is going to do it, the job that will handle it, and then I'm at the end of the wizard.
Cool.
So that's basic log shipping. Now, it's really beyond the scope of showing how to perform the recovery, but there are lots of good references when it comes to rolling over or taking a secondary server and putting it into production.
So the key there with log shipping is that we've got the ability to control the schedule of shipping, but there's still a time lag there, and we really don't have any failover capabilities. What's the next step in the progression here?
Let's see, did we take a look at strengths and weaknesses of log shipping?
Yes, we did.
We did. Okay, so next up, exactly like you said, having something that's a more automated failover, and that's database mirroring. So database mirroring entered the picture in SQL 2005, and it was a very exciting feature at the time, namely because a technology we're going to look at, failover clustering, was there. And it has certain strengths and advantages. Log shipping has its strengths and advantages, and neither of them addressed what mirroring did at the time. In the very, I have to give away a little bit of the end of the movie. In the very worst case of failover clustering, you could have a very long failover time. Automatic, but it might be long.
All right, well, let's hold off on that.
Yeah, we'll have to hold off on that and take a look at mirroring. So same general pattern. What are the basics? How do I set it up? Strengths and weaknesses, etc. So let's go, let's take a look at the basics. So I have one instance, we'll call it the principal instance, and it's serving a production copy of the database.
Okay.
Now, with newer .NET technologies that were out at the time, I don't remember what .NET version, maybe even 2.0 back then. But anyway, that's immaterial. So with a newer .NET connection string technology, you could not only have a primary a connection string, but an alternate server name in the connection string. And this is part of the automatic client failover trickery.
Okay.
So I have to have a recovery model. I don't know if it has to be full, but you would only set it up in full. You wouldn't even use bulk log. And essentially it works like this. I have a secondary server, and on a transaction by transaction basis, I have transactions going over the network, maybe to the same data center, maybe anywhere where I have IP connectivity in my network. And picture people marching together, left, left. Transactionally, each copy, transaction by transaction, are kept consistent.
So it's almost like log shipping with no delay.
No transactional delay whatsoever because, well, actually, with 2 out of 3 of the options, one of them actually allows a delay, but hold that thought for a sec.
Okay.
So I have perfectly transactionally consistent copies of my database. Now,
but we're still on a one database at a time instance.
yeah, this is
Right?
This is protecting on a per database instance. Now, there's some overhead here, Rich. The database destination is inaccessible. It's considered to be in a perpetually recovering state, and so unless please don't keel over here, unless I set up database snapshots, which could
dear.
be, and they're not bad. They have a place. I like snapshots. But that is the only way that the destination copy is queryable. So am I going to set up mirroring on maybe, a 5 meg database?
Nah, I wouldn't.
I'm going to set this up on something that's more mission critical, which means I probably allocate a secondary box for this. So I might specify, another 5, 10, 20 grand server that basically is not serving another role unless something goes wrong.
A just-in-case server instead of a just-in-time server.
Exactly. All right.
So how do we set this up? How do we configure mirroring?
Alrighty. So looking at the configuration options, there are 3 possible ways we can set up mirroring, and I want to focus on the one that really is the jazzy one, the one that provides the best amount of high availability, and in fact, immediate, within 10 seconds failover guaranteed.
Sounds like a plan. If I'm doing it, I want to go for the best.
So I have a primary server, I have a secondary server, and I configure objects called endpoints, which for all practical purposes are listening ears that one machine uses to send transactions to another TCP/IP endpoint. So it has a port number. I'll configure authentication, probably configure encryption so that I don't have to worry about that data being intercepted.
Okay.
I have a second, so that's the primary and or the principal and the mirrored copy. I then also have a tattletale or a tiebreaker, and this is absolutely necessary for the automatic failover. It produces, well, a tiebreaker or quorum.
Okay.
So in the circumstance where the principal's unavailable to serve its role, you have to have quorum between the mirrored database and the witness, and within 10 seconds, the mirrored copy and the witness agree that there has been a failure. The final transaction is rolled back, and the secondary copy is put into production that quick. Now, that covers database failover. What about client redirection? Well, remember, in the newer, well, it was new back then, in the newer .NET connection strings, they also could list a secondary server. So client connections, after they had a hiccup connecting to the first one, you'd set up a retry, and they'd automatically reconnect to the secondary copy and be put into production.
That sounds pretty cool. That sounds pretty cool. Are there any geographical limitations or anything like that? Is mirroring restricted at all?
No. In fact, as long as I can reach from one machine to another via IP, then mirroring is a possibility. So this would cover, a catastrophic data center failure as well.
So theoretically, I could put it on a public internet IP address and mirror across outside of my own domain even.
I probably wouldn't do that. Probably I would have either tunneling connections, VPN connections among my sites, and this would be within my own personal network.
Security always comes first, doesn't it?
So mirroring strengths and weaknesses. One of the biggest advantages is that I have automatic database failover, automatic client failover, and within 10-second recovery.
Okay.
So those are some of the strongest features about it. Honestly, as you'll see, it's really not that tough to initially set up, especially if you use the graphical user interface.
Cool.
Now, log shipping we saw didn't require any specialty hardware. The other high availability technology at the time did, so that made mirroring look really nice.
Okay.
No specialty hardware. I can have mismatched hardware.
That's always a good thing.
Different CPUs, different memory, different vendor brands. None of that is material when it comes to mirroring. So weaknesses. Uh-oh.
Uh-oh.
The D word.
No.
Mirroring is deprecated. It is a dead man walking feature.
Please tell me, I'm going to try and give away a little bit of the end of the movie.
Go ahead.
Is there a replacement?
Thankfully, there is a replacement. That's
And we're
going to
be talking about it, right?
We will hopefully real soon, but yeah. So it's deprecated. I have to have 3 servers. I don't need 3 servers with log shipping. Have to have 3 servers in order to get high availability mode.
But the witness doesn't have to be anything special,
Doesn't
right?
have to be anything special.
Okay.
Mirroring has to be configured on a database by database basis. So if I had 10 production databases that I want mirrored, I'm going to have to configure mirroring on behalf of each and every one.
Okay.
So now let's multiply that. If I had 100 or 200 databases on an instance, that's going to be a lot.
All right.
Finally, no system database protection with mirroring.
Okay, so replication can't be used to protect system databases, log shipping can't be used, and neither can mirroring.
Nope.
All right.
This brings us, let's take a look at how we implement mirroring.
Absolutely.
And actually hold off on the screen for just a second while I get some things arranged. Okay, roger that. So I start off the same way I would often when in doubt, right-click. So I'll get properties of a particular database, and additionally, I still have a mirroring page.
Okay.
So I go to the mirroring page, and how about if I start up at the top? Configure security.
So they have to be able to talk to each other, and there's security involved in doing it.
Yeah, so if I'm shipping transaction logs, transaction by transaction, something has to do it. It is the agent. The agents have to talk to each other. So when I click on that button, yep, I'm going to have to walk through a wizard to configure how those agents will communicate. So after I start the wizard, it asks me, do I want a witness server? And remember, for the highest level of availability, the fanciest option, yes, I must have a witness.
Okay.
So after that, I have to involve the particular servers to configure. So now that I have identified that I do want a witness, I continue the wizard this way. So now configure the principal, meaning if I said that I want to have a witness, of course I have to configure the principal, of course I have to configure the secondary, and yes, I do now want to configure the witness, but first up is the principal. Now an assumption is made, if I started at a particular instance in a particular database, it must mean that instance, and I can't change the name right there. I can change whether or not I want encryption, and I probably want it. I can change the port, and I'm going to have to communicate with my firewall folks if I have VPN connections from site to site and I want to have cross-site mirroring. And an object, a listening ear object, is made called an endpoint, and I may have naming conventions I want to adhere to, so at least I get the ability to name that.
And that port is not the database engine port. It's a separate port that's set up specifically for mirroring, correct?
Absolutely. Now, a little bit of a fluky thing here. When I was running through this, I had all, don't do this in real life, I had all 3 instances on one machine just to reduce some of the moving parts. And that's why listener port 5023 was suggested. I can't have the same port used on the same machine.
Yep,
Normally,
makes sense.
Normally I'd have the same port across all of the machines, but I can't do this within one machine. So that's why a separate listening port was suggested. So I have a second instance, a different port, and an endpoint name. All right, from there, I have to validate identity by saying who I am and then finally configuring the witness. So pretty standard stuff there. Create an endpoint, port, etc. All right, have to validate identity to the witness, pretty straightforward there, and then supply service accounts on behalf of each of the instances. Remember, they may not be the same accounts.
That's true.
Please tell me they're different accounts.
I was going to say, if it's best practices, they won't be.
Yeah. So I walk through the wizard, and there I go. There's mirroring. Now, the fun part, so it'll show progress, and then ask me if I immediately want to start synchronizing transactions from the principal to the witness, and it asks me if I want to start mirroring right now or maybe later on.
Okay.
Now, after, and by the way, I clicked on start so that it would have started, and this is when I get back to the mirroring page, and there is a significant button here. Notice the failover button.
Okay.
So the failover button allows me to manually failover and gracefully. So I might do this for something like a rolling upgrade.
Okay.
So I apply a service pack on the secondary, on the secondary machine, reboot it, make sure mirroring is reestablished, fail over to that one, rinse and repeat on the primary, and then get back to my original configuration. If I need very high availability, I have to have a technology like this. All right, so this is where I would have manual failover. It would probably be a little bit more dramatic to see, pulling the network cable on an actual machine that's being mirrored and see it automatically fail over. That would be kind of cool.
Yeah, but we don't have multiple machines.
All right. So if I did click on the failover button, we'd see failover database mirroring will swap the roles of mirror and principal, basically go through the rollover process, and that's it.
So what's the technology now that's replacing mirroring? Where are we going with SQL Server?
All righty. So the hot technology, really a game maker, is a new technology in SQL Server 2012 called Always On. And this will be especially noteworthy after we look at our final technology because it really overcomes all of the weaknesses of all of the other models, the other high availability technologies.
So this is the last of the SQL Server options for HA.
Yeah, yep. So we have the standard plan of attack here, basics, how we implement it, failover, etc. So first of all, this is a new feature in SQL 2012, and we'll see that it provides failover for a collection of user databases. So I can have what's called an availability group, define multiple databases, and have multiple copies. See, my mirroring copy was not readable, and I could only have one.
Yep.
Here, I can have multiple copies, and I can fail over multiple copies at once. There's lots to like about this. Really only one drawback, but that's another slide.
Yeah, I was going to say, wait for the strengths and weaknesses. Don't give it
So,
away.
a collection of primary replica databases support read-write connections. A collection of secondary replica databases, up to 4, support read-only connections, but it requires a particular Windows feature technology called Windows clustering. So we'll find also, just like with mirroring, that we can have synchronous commit mode. That means before a transaction is considered committed, it has to have already committed on all of the destination copies. That's synchronous, meaning marching in step. Asynchronous would mean I send a transaction log over to a destination, I continue business as usual, maybe it commits right away, maybe it doesn't. And then we also have planned and automatic failover with no data loss, other than maybe the transaction that was in progress at the time.
That is pretty cool. How do I get this going? What do I need to do to put it together and make it work?
So each instance hosting an availability group must be a Windows Server failover clustering node. I have to add the Windows clustering feature.
So this is an OS level requirement.
That is an OS level requirement.
Okay.
And fortunately, building or using the failover clustering feature has gotten a whole lot sweeter over the years.
Okay.
Probably no surprise, I have to have the same instance collation on all of the possible member copies in the availability group.
Okay.
And then I have to enable the always on availability group feature on each instance, multiple ways to do that. After I enable it, then I walk through a wizard. It waves a wand. It waves a wand over a number of activities. You have to configure what databases you want to have as part of the availability group.
Okay.
You have to configure a database mirroring endpoint. Does that sound familiar?
Yeah, it does.
All right, so there's some familiarity there. Create an availability group listener, specify replica copies, and then select an initial synchronization option.
That's pretty cool. Now, what about failover? What happens with failover with always on?
Okay, so we have a couple different, well, 3 different failover modes. Automatic failover, which would be the most glamorous of them, and other than maybe the current transaction that was in progress, no data loss. Like mirroring, we also can have planned manual failover without data loss. And then in the case where we have some serious problem, but not an automatic failover, we can tell it, well, these are my words, dang it, failover.
Okay.
So forced manual failover, possibly losing transactions. So
And what happens when they do failover?
during failover, the failover target takes over the primary role, recovers its databases, and brings them online as the new primary. The former primary replica, when available, if it were to self-heal, let's say, maybe somebody did a server reset or something like that, will switch to a secondary, and its databases become secondary copies. Then, based on policy, the forms of failover that a given replica supports is specified by the failover mode property.
And so, okay, we've gone through all this. What are some of the strengths and weaknesses we can expect from always on?
Alrighty, strengths. Very fast and automatic database and client failover like mirroring.
Okay.
Very flexible configuration with multiple failover replicas, unlike mirroring.
That's cool. So you get more than 1 DB at a time.
Read-only access to replicas, which we did not get with mirroring.
Yay!
Can back up replicas to offload work, so take my replica, which is transactionally consistent, put the backup load on it rather than the one that's serving production.
So now I'm distributing my resource load using the always on, not just getting HA.
That's right.
That's cool.
No special hardware necessary, unlike another technology we're going to look at. And I can also span data centers because of having endpoints that are reachable across IP subnets. And
Very
my own
cool.
opinion, this is not particularly trivial.
No.
So that's it. It's not particularly trivial.
Yeah, it is an expensive option, but it gives you a whole lot of possibilities for both resource utilization and high availability disaster recovery.
As far as, I don't have a canned demonstration for this, but I actually can do better. Use Bing and find the URL for Microsoft Virtual Labs. I don't know if it's microsoftvirtuallabs.com or what. Somebody find that out. And there's actually a library of a bunch of different SQL Server specific virtual labs. They have 2 specifically on Always On. So guess what? You can put your own hands on it, run through those particular configuration labs. I think you'll find that interesting.
That is very cool, very cool. So what then is the last HA possibility that we've got here?
All right, the last one we take a look at is also tried and true failover clustering. Lots of places out there with failover clusters. So we have our typical blueprint here, basics, implementation, things like that. So let's take a look at the basics. With all of the high availability technologies, you must understand the scope of protection.
Yep.
What we're trying to protect. Now, what we're trying to protect with failover clustering is a hardware node failure. So should I lose all the power supplies of a machine, I have a motherboard meltdown, I lose availability of the hardware node, then the SQL Server service is going to roll over to another node and run on that machine. But keep in mind, the databases that are attributed to that particular cluster, as it's called, are not redundant. Their data is not redundant. The redundancy protection here is the server hardware node.
So we're not talking about data storage protection, we're talking about resource availability protection.
We are talking about hardware. Now, in order to implement this, I have a lot of hardware that I have to architect, and it's particular. This is partly opinion. Maybe somebody, there are others that might have other opinions. I think it's particular. So I'm going to set up my physical hardware first, install Windows, then I must implement a Windows failover cluster. It requires certain configuration, and then I'm going to add one or more additional nodes that will be part of the Windows failover cluster. The restriction here is that ultimately what I get is a portable name. I get a name that clients are going to connect to. That name and all the resources that pertain to it can run on one hardware node or can run on any other node in the same cluster. So only specific services and applications support this kind of behavior. So shared folders, a couple of other Windows key features, and then a couple of applications like Exchange and SQL Server. SQL Server, specifically with this, you must install after you already have your Windows cluster, and some other things occur after the fact. Now, architecturally, in fact, let's jump to the architecture diagram, and I think this is going to help point out some other things. So notice I need at least 2 physical nodes.
Okay.
Well, even the virtualization, I can actually virtualize a cluster. That's way too complicated to talk about right now. So the picture you're looking at really is more typical of something I'd see a few years ago.
So
but
two physically separate computers.
Yeah, 2 physically separate computers. Notice they're going to have a network adapter for clients to connect to. They're going to have a network adapter for their own personal traffic among those nodes in the cluster. And notice the heart there represents a 1.1 second packet. Every 1.1 seconds, the heartbeat packet is used to establish kind of a keep alive among the other cluster members. Now, the other part of this is that I'm going to have a storage area network. In the past, before SANs were popular, there were some other technologies, but essentially we have to have a technology that allows more than one possible box to control the same LUN.
Okay.
So this could be iSCSI, this could be a fiber channel, but I allocate resources such as, a bunch of disks for data files, a bunch of disks for log files, and then I have another resource which is called the quorum. The quorum, or as seen in this diagram, I have to have a tiebreaker kind of resource that says this is the node that's actually in charge. In the past, this would be just another small unit of storage, like seriously a few megabytes on the storage area network. These days, and more typically and better, this can just be a UNC file share on some third machine.
Awesome.
And I would say that's more typical. All right.
Awesome.
So after I have all this hardware set up, and word on the street has it that you want these machines absolutely identical.
Yep.
You're not always told that, but you want the same firmware in your host bus adapters, same motherboard, same network adapters, in the same slots with the same amount of memory and memory speed. I mean, you want them as identical as possible.
So once you've got all that configured and everything's good to go, how do we then deal with the failover process itself?
A couple other little architectural elements. After my Windows cluster, install SQL Server, and the portable name here, the SQL cluster, is what clients will connect to. And then we have failover. Let's say I have a hardware node failure. There's going to be a policy that says, if I have more than one extra machine in the cluster, prefer to fail over to this one, and will I allow it to be automatic, yes or no?
Okay.
So failover is determined by a policy. Now, there has to be quorum or agreement among the nodes in the cluster as to who is actually serving the instance.
Okay.
So this could be determined by a couple different ways: node majority, node and file share, node and disk majority, disk only. So you have options there. This is expanded from what you might have had maybe 10 years ago.
All right.
Okay, brace yourself.
I'm braced.
Now,
give it a ride.
Essentially, when my cluster fails over, the SQL Server restarts, and if I have 100 databases on that instance, we know every time SQL Server restarts, every one of those databases has to go through the redo and undo process. So failover in the worst of cases could really be lengthy, which means it's not quite as attractive as always on or mirroring. But it protects the entire instance, which the other technologies do not do.
Awesome.
A good point is that there's zero client configuration. Clients point to a portable name. So this pretty much dovetails into the strengths and weaknesses. Clustering's been around for a long time. That means a lot of people know about it, have established policies of how to do it, and setting up the hardware or validating that the hardware will work right is done with a nifty wizard, the Windows Cluster Validation tool. Weaknesses, specialty hardware required. It's more expensive. It requires more expertise. For those that don't know how to operate a cluster well, you may introduce the opposite of high availability. You may reduce availability by causing a problem.
Oh, yeah.
And then keep in mind, data is not duplicated with a failover cluster. So it's often the case, if you were to use this, you would combine it with one of the other technologies like log shipping or mirroring, or you're going to use always on.
Always on. That would be the one.
All right, Rich, so that wraps up all the stuff that I had for today.
That's awesome. George, I want to thank you for your time today.
Thank you.
Appreciate it. Also, for those of you out here on the view watching us, in the bottom of your browser, there is a poll. This poll is probably the one that we really hope that you would add your feedback into. It really is how we know how well we did and gives us a chance to get better in future ones. Again, thank you so much for joining us today. For George.
Thank you.
And Rich and everybody out in the back that helped out, Elise and Danny and Barry, thanks very much. Hopefully we'll see you again down the road. Have a great day. Whoa!
I want to put in a plug for your session on Friday.
Yeah, we'll see. We got another one coming up. Check the schedule on the web if you're interested. We've got data warehousing and SSIS in a day or two. Thanks again. Have a great evening, afternoon, morning, whatever it is, wherever you are.